Good morning, neurosurgery. Is it neurosurgery? Hi, Notando. Neurosurgery and Notando. Hello. Hello, hello. Hi, Ngosingipile. Okay, guys, we are going to be going through this paper. It's a 20 November 5th, 2025. Paper was written in one of the regions here this year. Some of you have not written paper 2, but this is a paper that was written in one of the areas. So I know that in some provinces and in some areas, some people have not written paper 2 yet. So we are going to be doing this paper, grade 8 and 9. All right, because the content in this paper is not just applicable to grade 9, it is also relevant for grade 8. So if you haven't written paper 2 yet, as I believe some of the learners have not in the country, some learners in the country have not written paper 2 yet. So if you're in grade 8 and 9, you have not written paper 2, then basically this is a live that you can be happy to have joined at this time. I was supposed to have actually gone live at 6, but I woke up quite late because I slept very late, and I'm very sorry about those who were intending to join the live at 6 a.m. I'm now live. So for grade 8 and 9 who are wanting to go through a paper 2, you have joined the correct live. So let's take this paper one step at a time and answer it before I really go that deep. For those who are joining this platform for the first time, the host, who is me, goes through exam papers, does maths for grade 8 and 9 in this particular platform. So if you are someone who is really maybe struggling or who just wants to level up in their maths performance, then this is the space to be in. I also have a YouTube channel. I repeat, I also have a YouTube channel. The YouTube channel is actually called Maths is a Game. The link to my YouTube channel is found in my bio. So if you go to the bio, you will find a link that is also referred to as youtube.mathsisagame. You can click on that link, go to the YouTube channel, and there you will find that there are videos that I've uploaded, but these videos are not of the greatest of quality, guys, and I repeat, they are not of the greatest of quality. Why? Because I simply take these videos that I have done on the live video, and I go and upload it as it is. All right, so you might find that at the beginning it does not really start the teaching immediately because I'm waiting for people to join, or as I'm doing now, explaining about other things. Then eventually I end up going into what I have basically planned for the day. So be patient when you go through or you go and enter into one of the videos and watch it. And like I said, I am not like anyone else, and the quality is not like anybody else's quality that you may have seen as far as the videos are concerned, and you may be very disappointed with the quality of the videos, but the content that I cover is probably very much quality. In between, obviously, the talking and all of that stuff, but the quality of the content is based, the quality of the content, the knowledge, okay, is really helpful. Currently, neurosurgery, I don't have material for people to basically study, all right, unless you become part of my community of learners that I basically that are the paying learners, if you want. Though there are learners who basically will end up learning. Okay, yes, Black Boy, you can always rewatch my live lesson on the YouTube channel. That's the point. So if you join in the middle of the session, or maybe you have missed something, you can always go and rewatch the actual entire session when I go through it. So if it happens that you need to leave, then I guess you have to leave. If there's other commitments that you have, then there's other commitments that you have. But you can always go and rewatch a session there on the YouTube channel. Those learners who become part of my community, they are paying learners, meaning I have made an arrangement with them and their parents, and they are learners that basically pay a certain amount every month. Those learners, they become part of my WhatsApp community. They get an opportunity to interact with me personally. If they have questions, they can ask me directly. If they are preparing for exams and tests, they are able to get past papers directly from me, and they are able to actually get live assistance and help at their fingertips whenever they need that assistance and help. And if it needs be, I can do video calls with them on WhatsApp when they need specific direct help. But those learners are learners that are part of my paying community, and so I have to make that arrangement with them and their parents, and then get that arrangement happening. So if you are a learner who would like to have that happen, you can always text me on the side so that I can give you details as to what the paying community of learners, what that entails, so that I can send you the required information. You can escalate it to your parent, then you can ask your parent, and then we can liaise with your parent and see how we can arrange together. Lastly, these holidays, guys, and initially I was intending to start this on the 15th of December, but it may happen that I start this a bit earlier. These holidays, I'm intending to also have a grade 9 in preparation for grade 10 pure maths for learners who are in grade 9. Those learners who are in grade 9 who want to prepare to do pure maths in grade 10, there will be sessions that I'll be doing in the holiday to prepare those learners for grade 10 and to get them in the game for doing maths in grade 10. So if you're a learner who would like to have that thing be something that you are a part of as well, you are also welcome to contact me on the side so that we can also, I can give you the information that you need as far as that's concerned, because that is something also that will be enjoyed by my paying community, not just every learner, but my paying community. Those learners, when I do lives, will have a chance of being invited as guests, and they'll be able to ask questions directly live. I don't accept guest requests, guys. Just willy-nilly. I accept guest requests from learners that, like I said, are part of the paying community, and that is something I'm starting to do only now. So please, guys, if you are in grade 9, you'll be doing pure maths next year, and you want to get prepared early before school start, then you are more than welcome to also send me a message on the side and say you're interested in being part of this, and I'll send you a message that you can give to your parent, and then your parent can give approval, and then being part of that paying community that will pay a small fee every month, then you can actually be part and parcel of that group as well. So that is just a little bit of information there, and I hope that is clear for everyone. So let's start. I think let's get started with what I'm going to be covering for grade 8s and 9s for paper 2 this morning. All right, let's look at this paper. So if you are in grade 8, you are in the right place, because this grade 9 paper is covering also the content that is relevant for grade 8. So don't run away and leave just because you see grade 9. Grade 8 and grade 9 work is the same. It's similar, guys. Don't for one moment think that, oh, I'm in grade 8, that the grade 9 work doesn't matter. No. Oh no, I'm in grade 9, the grade 8 work doesn't matter. You guys are doing the same work pretty much. So when you are in grade 8, in grade 9 you find yourself repeating the same work. So yeah, let's get into it. Choose the correct answer from the 4 options. Write only the letter in the space provided. Like I said, this live is for both grade 8 and 9s who have not written paper 2 yet. Okay, if you are here and you've written paper 2 and you just want to be here, then great, you are also in the right place. The sum of supplementary angles equals A 90, B 360, C 180, D 120. So the community in the comment section is saying what? Okay, so majority of you are saying C. All right, very good. I'm very proud. That means you guys understand the term supplementary, that this term basically says add up to 180. That's what the word supplementary means. Okay, supplementary means add up to 180 degrees. So definitely our answer will be what? It will be C. All right, those who said A, remember guys, what does this mean? This means complementary. Complementary. Right? Yeah. Then this here, 360 degrees, when angles equal 360, we say they are revolution. That's a revolution. Supplementary is 180. 120, well, we don't have a specific term that we utilize when we talk about angles that add up to 120. But if angles add up to 90, they are complementary. If angles add up to 360, we say those are revolution. Okay, angles. Then if they add up to 180, this is basically the term that fits this description. The sum of supplementary angles equals 180. Wait a minute. This is very interesting. You know, I'm looking at this statement again and I'm like thinking to myself, interesting. I think here the wording is also a bit deceptive now that I'm looking at it again. All right, but interestingly enough, I think that's what they had meant to say with this question was okay, let's move on. In a triangle, all right, it's just that I'm looking at the statement again and it's a bit interesting now that I look at it again, you know, underneath where, yeah, I don't know if their statement really was supposed to be like this, because I'm re-looking at this and I'm like thinking to myself, the sum of supplementary angles. What are supplementary angles? Angles that add up to 180. But now the sum of those angles. Very interesting, guys. That the sum of angles that add up to 180. You know? Yeah. No. It's definitely not A. Neurosurgery, it's not A. Because remember, 90 degrees means complementary. Okay? So it can't be A. It's not A. Alright? Initially, or what I'm thinking is it's supposed to be C, but you see the thing is if you're talking about supplementary angles, you are talking already about angles that add up to 180. So because of this statement and the English used here, I'm beginning to think that you are talking about those angles that add up to 180. Now you are talking about their sum, all right? The sum of those angles that add up to 180. So I'm beginning to think that the answer should be B, because if you take angles that add up to 180 and now you are doing what to them? You are summing them up. Those angles should basically give you 360 degrees as a total, right? But the funny thing is, what I do know for a fact is that, I've already marked learners that basically were answering this question paper, and when what the memorandum was saying was that the answer should be C, right? Which means the statement did not mean the answer that they had, or at least maybe the person who had written the question was meaning to say something else that refers to this answer, which is 1.1. But yeah, all right. So if I was to be honest, if I was answering this question really, then I would basically do that. Okay. Okay, let's move on anyways. Okay, so there's a bit of an argument there. Okay, definitely a bit of an argument there. So I would roll with B, to be honest. Dimples, it was to confuse us. Yeah. Okay, let's move on to the next question. In a triangle, if two sides and the angles opposite the equal sides are the same, the triangle can be classified as a equilateral triangle, B isosceles, C acute angled triangle, or D scalene. In a triangle, if two sides, now you imagine this, guys, these are two sides, this would be two sides, and the angles that are opposite these angles opposite the equal sides are the same. So you're talking about these angles, two of them, they are both equal. Okay, this angle is opposite that side, this angle is opposite that side. So definitely it's not an equilateral triangle, because we know an equilateral triangle has all three sides equal, right? So it's not an equilateral triangle. Isosceles, yes, it fits the mold of isosceles triangle. Scalene means all three sides are unequal, so it's not that. And then acute angle triangle, that's an angle, that's a triangle that has all angles between 0 and 90. There's no angle that is greater than 90, but all angles are between 0 and 90. That's what an acute angle triangle generally is. So specifically, guys, the answer that is applicable to this statement is definitely what? B. So we would write there B as our answer. Okay. Yeah. Let's move on to the next question. To prove similarity, okay. Now this term similarity, all right. The following is true. S, in other words, side, side, side. B, A, meaning angle, angle, angle. C, corresponding sides are in the same proportion. Or D, option B and option C. So which statement is true when we're talking about similarity? Now guys, I just want in this moment, because we are answering this question, to sort of like look at what similarity actually is, so that we can then see which answer is relevant. Similarity has to do with, if we're talking about triangles, right? If we are referring to triangles, generally when we're talking about similarity, we are talking about shapes with equal angles, all right, but proportional sides. Proportional corresponding sides. So it would be like having this triangle, but then having the very same triangle just a little bit bigger. So which means that we have increased, the scale factor of the sides of the triangle, whereas the angles are identical, they are equal. So that angle is equal to that angle is equal to that one, and that angle is equal to that angle. So the corresponding angles, they are equal, but the sides are not equal, but we say that the sides are proportional. In other words, the sides are in the same ratio. The scale factor, all right, of the sides. So yeah, they increase by the same scale factor. So for instance, if let's say I had 3 as the length of this side, say now for instance we say that this side is 6. If this side is 4, say now this side is 8. If this side is 5, say now this side is 10. So in other words, if you look at what has happened with the sides that are corresponding, this side and this side, they are in the same ratio. The scale factor in which we are supposed to, from this side, get this side, we are multiplying 3 by what to get 6. We are multiplying 4 by what to get 8. We are multiplying 5 by what to get 10. All right? And vice versa. From 8 to get back to 4, we are dividing 8 by what to get 4. We are dividing 10 by what to get 5. We are dividing 6 by what to get 3. So there's a scale factor, all right, that we are seeing that the sides, either from the small to the big, increase by for the corresponding sides, or there's a certain scale factor that the big triangle is decreasing by to get to the other side of the triangle. So we say as a fact that the shapes, both of them, have what? Equal angles. So that is why we talk about angle, angle, angle. So in other words, this angle is equal to that one. That angle is equal to that one. And that angle is equal to that one. That's how many pairs of angles that are equal. We have 1, 2, 3 pairs of angles that are equal for similar triangles. 2. So that's the first thing. The angles, all right, the corresponding angles are equal. 3 pairs of corresponding angles are equal for similar triangles. Then 2, we say also that the sides are proportional. The corresponding sides are proportional. In other words, they have the same ratio. They increase by the same scale factor. You do what to 3 to get 6? You multiply by 2. You do what to 4 to get 8? You also multiply by 2. You do what to 5 to get 10? You multiply by 2. So we can actually write the corresponding sides. First ratio is 3 over 6, 3 over 6. Second ratio, 4 over 8, 4 over 8. Third ratio, that's corresponding sides, is 5 over 10. All right. And if you simplify 3 over 6, you get half. 4 over 8, you get half. 5 over 10, you get a half. So what you are witnessing here is that the sides of the triangle are in the same what? They are in the same ratio. The word ratio is the root word for the name or the word rational. And the word rational, we understand that it means fraction, where A in the numerator and B in the denominator are integers. So that is why we say that the sides for similar triangle are in the same ratio, or we can say the corresponding sides are proportional. All right, I hope that makes sense to you. So that is why when you talk about similarity. You have to check similarity either using one of two ways. One, angle, which means equiangular. What does equiangular mean? Equi means equal. Angular refers to angle. So three corresponding angles are equal. If you can prove that, then you can conclude that the triangles are similar. Or you can use proportional sides. If you can prove that the corresponding sides of the two respective triangles are in the same ratio 1 for a pair of sides that are corresponding, ratio 2 for a pair of sides that are corresponding, ratio 3 for a pair of sides that are corresponding. You check the simplification of these sides, you realize that the ratio is the same. You can also then conclude that the triangles are what? Are similar, and the reason is what? Corresponding sides are in proportion. So let's go back to the statement here. It says, to prove similarity, the following is true. Right? To prove similarity, the following is true. Is it A? Side, side, side. In other words, the sides are equal. The sides are equal. Is this the true statement about similarity? No. This is not talking about similarity. It's talking about another topic which we call congruency. And congruency is different from similarity. B, is it A, which means, in other words, the first A, the first pair of angles, second A, the second pair of angles, third A, the third pair of angles are equal. Is this true of similarity? Yes. C, corresponding sides are in the same proportion. Is this true of similarity? Yes, it is true of similarity, meaning these two statements B and C are true. Option D, option B and option C. Who is option B? It's here. Who is option C? It is there. So is option D the actual correct answer? Yes, guys, it's option D, because it is talking about both option B and option C. So therefore our answer, guys, is D, option B and option C, because when we talk about similarity, what did I say we mean about similarity? We mean for triangles, either three pairs of corresponding angles are equal. A, that's one case. Or two, we mean by similarity that the sides that are corresponding are proportional. All right, and I explained what this proportionality of sides actually means. The sides are in the same ratio. So both B and C are correct. So we choose D because option B and option C is what similarity actually means. Okay, I hope we are clear. Can I just get confirmation in the comment section that we understand and we are moving together as far as what similarity means? So even if you were not taught similarity very well, I hope at least you have a bit of light about similarity. That in order for similarity to hold, in order for similarity to be confirmed, the idea that two shapes have the same angles and two have the same, not the same angles, but the sides are in the same proportion, then we basically know that similarity means B and C, and therefore the option here that we choose is option B and option C. Okay. Thank you, account not found. I really appreciate the rose and the support. It means a lot. All right. More so today, the support I appreciate because it is my birthday today, like just so that people know. So I appreciate the support. Yes, for the live lesson that I'm sharing with you guys, but also so much so because it's a significant day for me. 1.4. Thank you, Stana Later. Really appreciate it. ABC is an equilateral triangle. So let's look at this one. ABC is an equilateral triangle. So we are being told it's an equilateral triangle. That's very important. Thank you, Just Chill. Really appreciate it. Account not found. Thank you to all of you for those birthday wishes in the comment section. Means a lot. So ABC is an equilateral triangle. If you look at the diagram, you can see the A, you can see the B, you can see the C. Does that make sense, guys? Thank you so much, guys. I love the warmth of the messages. Thank you. ABC is an equilateral triangle. So yeah, hopefully in our heads, immediately when it says equilateral triangle, you know, we are thinking of the sides of course that are equal, but also we're thinking about the angles which individually are 60 degrees. Don't worry, I'll post this, guys, on my YouTube channel. Chill. Okay, so those are the two things that should come to mind as we think of an equilateral triangle. Thank you, Victoria. Okay, sides are equal, all three, and then obviously each individual angle is 60 degrees. Thank you, Notan. BC is extended, as it says. BC is extended to D. There we have it. BC is extended to D. So that angle CAD, guys, I hope all of you understand. When you see this and they say angle CAD, this refers to the middle letter as the angle that they are specifically talking about. So you go to your triangle, you go to C. Where is C? There is C. You move in the direction of the letters, and then you mark the middle letter because that's the angle that is 25 degrees. So it's CAD, middle letter. There we are, 25 degrees. Then lastly, they are asking, what is the size of angle? Angle what? ADC. They have a question mark there, so they wanted the size of this angle. Okay. Now, immediately when I have read the statements, and from the statements, the certain information I've got, I go into the diagram and I start writing down what I know is relevant for the diagram that I do not see with my physical eyes. Right? Then, as they're asking this question, I can now go ahead and say, all right, they want the angle D. Then it's fine, I'll calculate what the angle is. Before that, I'm gonna ask, how many triangles are in this diagram? How many triangles, guys, do you see in this diagram? Can I ask you that question? Let's see if people know how many triangles are in this diagram. Now, based on your answer, I will see if whether your mind sees things as they actually are or sees things as in the way they think that they are. So if I was coming to you and I was saying, guys, how many triangles do you see here? If you are saying 2, then it means you have a limited scope of sight as to how many triangles there are. Guys, you can see there's triangle. Let's identify. Triangle ABC is obvious. Then there's triangle ACD. Then there's triangle ABD. The actual triangle ABD. So in total, there are 1, 2, 3 triangles. Not 2, guys, but 3. So knowing that is very helpful. In triangle ABC, I have all my information. In triangle ACD, I don't have all the information. I'm missing 2 angles. This angle that is exterior, all right, to this triangle, and it really is an exterior angle, this angle. And I'm missing the angle that they want me to find. They want me to find angle ADC. So I follow the direction ADC. And we said that the middle letter is referring to the angle. Let's never forget that, guys. So this is the angle that is missing or that they want. So from what I can see here, there are 2 possible ways to find angle ADC. So one learner may look at this and be like, okay, angle B and angle A I have, all right, they are both 60. So I know the theorem that says the exterior angle of a triangle, so is equal to the sum, okay, of the two exterior angles. You see, these people are saying, why am I taking long? Remember, not all of you are in the same page. So it's helpful to other learners that are on the live. You may be fast and quick because you know what to do. But remember, there's a diverse breed of learners that are on the platform right now. So if you're getting impatient, Lee, if you're getting very impatient, then please don't, I don't know, you need to learn to be patient, because I'm not accommodating just you. I'm accommodating other learners that may probably not know how to go about or even start. So I'm also exposing them to the method and the way and the strategy to approach questions. So you need to be a bit patient. Okay, so I'm saying there's one of two ways you could answer this question. If you are looking at this triangle, you can see that angle ACD, this angle ACD, guys, is an exterior angle of this triangle ABC. So what is ACD equal to? Tuto is saying 3 ways. Actually, that's great. Tuto, I love that you are seeing 3 ways. All right, and obviously there is the awesome. You are right. You are correct, Tuto. I see the 3rd way. So just as there are 3 triangles, there are 3 ways to actually answer this question. I love that, Tuto. So if you look at these two, okay, these are 2 interior opposite angles. They are equal to the exterior. So angle ACD, guys, is actually equal to what? 60 degrees plus 60. All right, so if I was answering the question, I would actually mention that and say exterior angle of triangle as my reason. Then I find angle ACD is equal to 120. And then the 120 would be there. Method 2, let's say I did not use that approach. All right, I could also have found angle ACD. How? I would have said angle ACD plus angle ACB is equal to 180, because these 2 angles, they share a common vertex. They lie on a straight line. And if angles share a common vertex and they lie on a straight line, we can add these 2 angles together. Now, I didn't know what this angle is, but I would find it and say angle ACD is equal to 120 degrees. The reason in this case would have been angles on a straight line. All right, so this is one way of finding angle ACD, 120 degrees, using exterior angles of a triangle. That's one person's way of how they could have thought. Another person could have thought of seeing, oh, this is 60. Therefore, this angle is 120. Why? Because these 2 angles, what do? They complete a straight line. From here to there, from there to here. These angles share a common vertex. They are next to each other, meaning they are adjacent to each other. So if this is 60, then that is 120. All right? Yeah. That's one of the ways. Now, after you find the angle 120, what do? You go to triangle. What? Triangle ACD. And then in that triangle, in triangle ACD, what do? We now have 1, 2 angles, and we are missing angle ADC. So angle ADC plus the 25 degrees plus the 120 degrees would have been equal to what? To 180. And what would have been the reason? Sum of angles in a triangle. And then what would we have done? We would have transposed the angles to the other side. 180 minus 120 minus 25 degrees. And then you guys have been writing the answer in the comment section, and have been saying that the answer is what? Angle ADC, 180 minus 120, that gives us 60, of course. Then 60 minus 25. That gives us a nice answer of 35 degrees. So the answer is 35 degrees. So one of 2 ways of getting to the same answer. The 3rd way, okay, so hopefully you guys understand, okay, and I think both of these ways would have first been, prepared by me saying angle ACD is equal to 60 degrees, the reason being equilateral triangle. That's where I would have started first, okay? angle ACD is 60 degrees, I would have started there and said it's 60 because it's given to me that ABC is an equilateral triangle, and I would have started there, then moved either in this direction, which is option 1, or moved in this direction, which is option 2. Either seeing that ACD is 120 because of exterior angle of a triangle, or seeing that angle ACD is 120 because of angles on a straight line. Then from there, I go smack bang into triangle ACD. Add these two angles together, add that angle which I don't know, and say they are equal to 180 because those are supplementary angles, sum of angles in a triangle. Then solved for angle ADC by taking 125 over, taking 120 over, subtracting, and then getting the angle ADC, which is 35 degrees. All right. The last way, the third way we could have done this question, if you look at the triangles that we have this angle for triangle ABD. We have this entire angle for triangle what? ABD. Then we are missing this one for triangle what? ABD. So one other person could have done this, taken in triangle ABD. So after saying ACD is 60 for equilateral triangle, the third way we could have gone is then go into triangle ABD. Then do what? Take these angles 60 plus this angle 60 plus this angle 25 plus the angle that I want, which is triangle ADC, and say it's equal to what? 180 degrees. Reason? Sum of angles in the triangle. And then ultimately what do? We take all of those angles, we transpose them to the other side. So 180 minus 60 minus 60 minus 25, we still get the same answer for angle ACD, which is 35 degrees. Okay, still get the same answer, which is 35 degrees. So guys, I've just exposed you to one of 3 ways to getting to the same answer. Okay, and yeah, hypothetically, I don't know what time I'll finish. So hypothetically, I don't know. Okay. Next question. The figure below shows an isosceles triangle. What is the value of M? Okay. Let me just remove this grade 8 and 9. I think you guys all know now it's grade 8 and 9. So what is the value of M? A 40 degrees, B 50 degrees, C 60 degrees, D 70 degrees. Okay, so I see majority of you are saying A, but there's someone who is saying D. The person who's saying D has a misconception, and I'll tell you the misconception that the person who's saying D has. So if you look at the triangle, this angle here will be equal to what? Since this is 70, what will this angle be equal to? Because that's important for us to understand. If this is 70, what is this angle equal to, guys? This one, the one that I'm pointing to. Hi, Tracy. If this is 70 degrees, what is this angle equal to? Very good, Tebukhomila. This is also 70. And you would say this angle is equal to 70 for the reason that angles are opposite equal sides. That's why this is 70. Then it means the only thing now that you need is then find the value of M. And in order to find the value of M, what do you know about the interior angles of a triangle, the sum of interior angles? You know that the sum of interior angles of a triangle gives you 180. The sum of angles is 180. angles are supplementary for a triangle. So that means then all you need now is make up 180, like user is saying. So 70 plus 70 is 140. What are you missing in order to make up 180? If you have 70 plus 70, what are you missing in order to make 180? For the reason that sum of angles in a triangle, we know we are missing 40, guys. So that means our M value is definitely 40. All right, so you guys are correct when you say A. Those who thought it was D, please look into the misconception you have, because you can't be having this kind of misconception moving to the exam. 1.6. ABCD is a quadrilateral. ABCD is a what? Is a quad. What is the value of A? So in this quadrilateral, we have 1, 2, 3 angles that are given to us. But angle A, we don't know. So the question is, what is the value of A? So first question is, what do we know about a quadrilateral? Quadrilateral, quad means 4. Lateral refers to the sides of the four-sided shape or polygon. Okay. Furthermore, we also know that the sum of the angles in a quad is 360 degrees. Exactly. The angles are supposed to make up 360. So if we have 105, 93, and 47, what do we need to make up 360? You know, that is the question. What do we need in order to make up 360? Okay. Okay, is it A, do we need 105? B, do we need 115? C, do we need 120? Or D, do we need 125? Okay, so yes, indeed, we can add up all these numbers. We can add up all these angles, and after doing so, subtract 360 from them. All right, so if we were, let's say, for instance, answering this question and there were steps required, we would actually do this. A plus 47 plus 105 plus 93 is equal to 360 degrees. And our reason is sum of angles in a quadrilateral. And then we would actually take everything over. 360 minus 47 minus 105 minus 93. Remember, when we take things over to the other side, the signs of the angles change. So this was positive, all of these were positive, they changed to negative on the other side to subtract from 360. And then we get an answer of 115 degrees. So those who said B, guys, 100% spot on. Okay, statement, reason, simplify the answer. All right, but of course, if you're doing the multiple choice, really and truly, it's very important to be able to do that. So all in all, the answer here is B. We would obviously write the answer there because they said in the space provided, we write the answer, the letter, guys, not the value. You know, hey, I don't know why learners do that. You write down the letter here in the space provided because the instruction says so. This instruction says choose the correct answer from the 4 options, write only the letter in the space provided. So don't do things in a funny way here. 1.7, study the pair of shapes below which 2 shapes are congruent. 2 shapes are what? Congruent. Now this word congruent means same identical shape. Same identical shape, meaning equal sides and equal angles. Congruent means twin, and it means identical twin. Okay. Okay. So would this be congruent, guys? Okay. Would this be congruent? Would this be congruent? Would this be congruent? Okay. Right. And look at this now. Okay. So you've identified the one that is congruent, but look, you have the option. Is it shapes D? Is it shapes A? Is it C shapes B? Or is it shapes C? Right? Yeah, so this question was a bit tricky. I saw learners, for instance, say D is the answer because they looked at the shape there and they're like D. No, but D says shape C, so meaning they are saying this answer. Is it this one? No, no, no. Okay. So what is the answer? Okay. So from what we can see here, we see that this is the answer. But then what is the option we choose based on the statement? It has to be A because shapes D is the answer. All right. All right. Guys, not to be rude or anything. If you are someone who's here and you feel like this is a waste of your time, please do leave. Please do leave. Your negative energy, that negative energy that you have is the energy that I don't need in the life. So if you feel like you're sorted, you know what is to be done, please leave so that you can allow those who are here to be here and to get and benefit from being here. All right. So I encourage you that if you don't want to be here, leave. If you just want to get the memo and get the answers, I'm wasting your time, I'm going too slow, or anything like that, please leave so that you can allow those who are here to get the full benefit of being here. All right? Please, 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 I beg you. And that is not being, that's courtesy. When you decide, when you see that this is wasting your time, you save yourself, you leave so that you can allow others to be here. Okay? Yeah. Thank you so much for the rose. Really appreciate that. Next one. 1.8. In PQRS, PR, here's PR, guys. Okay, I love this PQRS. When you read something, come back and see if what you read is actually PR, which is PR here, intersects. This word intersect. This has to do with lines that cross, touch, overlap each other at a specific point. So PR intersects with QS. That's just cutting each other, guys. At what? At T. Such that it says PT is equal to TR. So I could actually put this in here. All right, those two are equal. And it also says QT is equal to TS. So in other words, QT is also equal to TS. Now, from this diagram, they are saying PQRS is therefore A. Now, I know, guys, when you look at this, as per the scale of what you are seeing, I know what most of you think this is. But you're looking at the options and you're like, okay, they're saying a rectangle. A rectangle. Okay. Now, when you look at it visually, you're like, rectangle makes no sense. Yeah. But this property here that says PT is equal to TR and QT is equal to TS, when it comes to these two lines, which we call diagonals, these lines apply to a rectangle. The fact that PT is equal to TS and QT is equal to TS, that applies to a rectangle. But when you look at the angles, you're like, these angles, they do not basically give me a picture of 90 degrees. So it can't be rectangle. B, trapezium. Trapezium. Guys, a trapezium only has one pair of parallel sides. The diagonals of a trapezium anyways are not what? They are not they do not bisect each other like this, right? Now let's look at C, rhombus. Now you look at this as per your scale. This diagram, if you look at PS and QR, you look at PQ and RS, right? You do not per se, according to the scale of the diagram being drawn, see a rhombus per se, because you look at this and you're like, it does not really equate to all four sides being equal. But there's something that is usually said in the instructions of your question paper. I want you to look at this. Oh, okay. Sorry guys for the delay there. This statement here: diagrams are not drawn to scale. Diagrams are not drawn to scale. Right, that was an unleashing of a shoot. There was a shoot out there. So if you come back here, well, the diagram is not drawn to scale, but the property of PT is equal to TR and QT is equal to TS, very much relevant to a rhombus as well, just as much as it's relevant to a rectangle. But also, if I look at the fact that the angles don't give me 90, but they are more bent towards how the diagram of a rhombus would be, right? It seems like this is more applicable. The best answer we can actually choose. Okay, thank you so much, neurosurgery. I really appreciate it. D, is it a kite? I really appreciate the birthday wishes. Thank you so much. D, is it a kite? Definitely not. So definitely the answer, guys, is what? It's C. Okay, it is C. It is definitely C. Okay. Now 1.9. This is applicable to grade 9s. So this question here will be applicable to grade 9s, not necessarily our grade beautiful what? Our beautiful grade 8s. Okay. Yes, Mr. D, I said so. Yeah. You, in your mind, look at this and you're like, it's more of a parallelogram than anything. But remember, from our options, we don't have parallelogram. So we need to choose the next best answer from the options. Okay? Okay, we have to choose the best answer. So rectangle is not the best answer. Trapezium is not the best answer. Kite is not the best answer. It more of like attunes to rhombus. Okay, that's the best answer for this diagram, because the option parallelogram is not here. But if the option parallelogram was here, we would have probably chosen parallelogram more than rhombus. So we choose the best answer. This is very important when you are doing multiple choice questions. Multiple choice questions is about choosing the best answer. Okay? Yeah. And I love what somebody said in the comment section. They said, Debucho says in grade 11, we have those grade 9 things to mathematics. So mathematics does not change. Guys, these are the basics to the grades that you are going to. If you're in grade 9, going to grade 10, you will basically have to have these basics, and you need to have these basics very strongly, okay, because that's how things are able to go well in grade what? In grade 10, 11, and 12. The problem says that the diagonals of a rhombus bisected 90 degrees, rejecting a rectangle. Yes, rejecting a rectangle. I think you wanted to continue your statement. All right, so I know that the diagonals of a rhombus bisected 90, and we are not told that the angle here is 90 degrees. Neither are we told that the angles here are 90 degrees. Does that make sense? But like I said, the best option we can actually choose from the given options that we have is that of rhombus, because of the sort of like I usually say that a rhombus is a drunk A rhombus is a drunk square, right? And I usually say that a parallelogram is a drunk rectangle. It's not straight. It can't stand up straight, meaning it can't be 90 degrees perpendicular, if you know what I mean. But it's kind of like a lazy square and a lazy rectangle. So in this case, yeah, C is the best option. So let's move on to this one. The transformation of triangle ABC, and triangle DEF is called A. Transformation from ABC, this triangle, to triangle DEF. Is it A, reflection? Guys, remember, with reflection we have reflection in the x-axis, reflection in the y-axis, and reflection along the line y is equal to x. So if we look at this triangle, all right, what's important here with this triangle and that triangle, we can see this one is here, but this one is on the other side of the y-axis. Seems like it's moved to the side, all right? In the same position it's moved. It has not reflected. Because remember, guys, if it had reflected, it would have been a triangle like this looking at that one. Okay, a reflection does that. If it is along if it's along the y-axis, plus the distance from here to there would be the same distance from here to there, but this triangle would be looking in that direction. So it's not reflection. It's not reflection at all. B, reduction. Now, this triangle, if it was reduction, this triangle would be smaller, would have been reduced, all right, from this one. Okay, but it's not like that. So it's not B. C, enlargement. If it was enlargement, this triangle would have been made more bigger. It would have been multiplied by a certain scale factor so that the sides are bigger. Same triangle, but bigger sides. Okay, that's what enlargement is. D, translation. Translation has to do with the movement of the specific two-figure shape, up, down, left, right. So here, look at this. This has moved to the right. Okay, and it's moved to the right by a certain number of units. All right, it's only moved to the right, nothing else. So that speaks to translation. And remember, guys, reflection and translation does not change the size of the triangle or the size of the shape, whereas reduction and enlargement, they actually change the size of that particular shape. Okay, so we could have looked at these two options as our possible options, reflection and translation. Why? Because the shape is still the same size. Reduction and enlargement, we look at it the moment we see that, oh, this shape is bigger or smaller than the other. Okay, so since it's the same size, that's why we don't even consider reduction and enlargement, but rather, because it's the same size, we can look at reflection, but with reflection, we need to check, is there a sense of the other one looking at the other one from a certain axis, all right? And you can see reflection is not it. D, translation, is there movement up and down, left and right? Well, there's movement of this entire ABC to the right. And we can even check how many units it moved to the right. You compare C with F, you can see the x value here is -4. The x value here is +3. So from 4 to 3, how many units? We can count. 1, 2, 3, 4, 5, 6, 7. So we moved 7 units to the right. Does that make sense? You look at B, compare it to E. B, -6. E, +1, the x value. You count how many units did you move to the right. Same thing, 7 units. You look at A, you compare it with D. A, -6. D, 1. How many units did we move? You see, so it's 7 units to the right. Like somebody in the comment section had indicated, its movement to the right. So we are adding to the x value 7, whilst our y value is doing what? It's staying the same. So all in all, That's what we talk about when you talk about translation. It's the movement. Up and down movement affects our y value. Left and right movement affects our x value. All right. So I hope that's clear for everyone. 1.10. If triangle 1 below, this is triangle 1, is enlarged, there we go. It's what? It's enlarged so that the new triangle is 12 centimeters high. So think about it practically. Now we have a triangle that's 12 centimeters high. This one was 4 centimeters high, this one is 12 centimeters high, and 9 centimeters long. 9 centimeters long. 9 centimeters long. This was 3 centimeters, this one is 9 centimeters long. And then lastly, what was the scale factor of the enlargement? Okay. What was the scale factor of the enlargement? Oh, let's say D, I'm sorry. Write the answer for 1.9. It's D. Sorry, my mistake there. Thank you, let's say D. What was the scale factor? Guys, do you understand what a scale factor is? You go to grade 10, 11, and 12 and you don't understand scale factor. But in lower grades, you learned about scale factor. Guys, we need to understand what scale factor is. So the scale factor is the number that you multiply by, the ratio you multiply 4 by to get 12. Okay, that's what an enlargement of a particular shape means. What did you do to 4 to get to 12? What did you do to 3 to get to 9? So here, if we compare a big to a small, we say big 12 divided by small 4. If we want to check what happened from small to big. If we want to know what happened from small to big, then we need to do that. All right. So what's 12 divided by 4? Guys, you can see it's 3. Right? Look at the same long side. This is the 9 centimeters long. So 9 centimeters, 12 centimeters high means this. 9 centimeters long means that. So you compare this with that. What do you see? Big over small. So that means what? 9 divided by 3. What's 9 divided by 3? It's 3. So guys, this is the scale factor of the enlargement. The scale factor of the enlargement is C. Okay? So in other words, it's 3. Had they asked what will be the length of the missing side of the other triangle, it would have been easy, most, because we know that the scale factor. Gamer Ashton, you are very rude. Very rude, my guy. Very rude. So I'll give you a chance to redeem yourself. Maybe you can apologize, not just to me, but to everyone in the platform. But if not, then I guess you will have said that you don't want to be here. So I would gladly block you. But you can redeem yourself. I do understand that people come into the live session sometimes and they will just want to be funny, or they want to be, they want to be dramatic. So you can redeem yourself. You can ask for forgiveness to those who are here for saying what you said. And then, yes. Yes, I'll post this. So yes, if we would have been asked what this side is, then we would have times the side by 3 to get 15. Okay, and we would have gotten that. Okay. Let's move on. Study the figure below to complete the sentences. QP, here is QP, and VW are straight lines. For each of the statements below, select the correct answer by writing the letter that corresponds to the correct answer in the space provided. So if we look at the diagram now, we are told QP and VW are straight lines, but we can also see furthermore that these are parallel lines. Okay, that line is parallel to that one. This UT and SR are what we call transversal lines. Transversal lines. Okay? And around where the transversal lines intersect are angles formed. Okay? You can see these angles that are formed. And between parallel lines, by now we should know that there's these relationships that we know because of FU and N. The F-shape relationship, which has to do with something being 180 degrees. The F-shape has to do with angles being equal. U-shape relationship has to do with angles adding up to 180. And then N-shape relationship has to do with angles being equal as well. So equal angles for F, angles adding up to 180 for U, and then for N, angles being equal. Where are these angles? These angles being equal for N that is well-shaped, or Z that is well-shaped, also for Z that is not well-shaped. These angles are equal. We call them alternate angles. Alright. These ones, the armpit angles, where it stinks, I call them the stinky angles. Okay. What do you do to stinky armpits? You add roll-on. You add deodorant. So we add these angles. They sum up to 180. We call these co-interior angles. Okay, and whenever we use them, don't ever forget to state your parallel lines. They add up to 180. Then lastly, our F shape. Top on top of each parallel line, there are angles formed. Bottom of each line, there are angles formed. So top angles are equal, we call them corresponding angles. And whenever we give this as our reason, we state the lines that are parallel. So top angle is equal to top angle, corresponding. Bottom angle is equal to bottom angle, corresponding. That's for the F shape. Okay. So corresponding angles, alternate angles. Those angles, we say that they are equal. The position for corresponding, on top, we are equal. On the bottom, we are equal. That's corresponding, our F shape. N or Z shape, those angles, we say they are equal. And then co-interior angles, guys, the armpit angles, where it stinks. And those two angles are not equal, but they add up to 180. Okay. Now, let's look at this diagram, because and let's not forget fun X. Yeah, they usually say it's fun X. So this is only relatable. The FU and the N have to do with lines that are parallel. The angles are only equal if the lines are parallel. But for the X, we say these angles are what? Again, guys, we call them vertically opposite angles. That angle is equal to that one. We also say that one is equal to that one. So we want to match Kenguku. Angle A and 70 degrees are angle A, this angle, and 70 degrees are. Let's choose here. Is it A? Is it B? Is it C? Is it D? Is it E? What do we write here for our answer? Angle A, this angle there, and 70 degrees are what angles? So you guys are correct. They are alternate angles. So the option we choose here is E. You guys are 100% correct. You guys are amazing. Now, I would personally update my diagram and write that 70 there so that I know, all right, that they are alternate angles, they are equal, and that is 70 degrees. Angle B equals what? Angle B equals what? Is it 70? Is it corresponding? Is it 165? Is it 95? Or is it alternate? So this one is gone. Is it D, 95 degrees, C, 165, B corresponding or 70 degrees. Now they're saying angle B is equal to, and they have degrees, so we need an angle here, guys. That's what we need. We don't need a description, so this is not going to be something we'll be writing. We're either writing this, that, or this. So angle B here is what angled? Okay, now I see in the comment section most of you are saying D. Lone 4 is saying D. Njabulo is saying A. So Njabulo is saying that this angle is 70. Guys, is it correct to say that this angle is 70 degrees? Right? Maybe Njabulo is looking at this angle and looking at that angle. Remember, these lines are not parallel. So the relationship between this angle and this angle is not there. Okay, this is not a relationship of angles that we can put under F, U, N, or X. So we need to look at this angle with that angle. Since we know this angle, we need to look at this angle with that angle, because these two angles are between parallel lines. So our U shape is truly a U shape in this sense. Does that make sense? Because these are parallel lines, Jabulo. But those lines are not parallel, so we can't look at U shape here. We look at U shape in this sense. We have this angle, we have that angle. The word co-interior, go inside. I like this. I like this. JJ Boshoff. Co. I love this. I love this comment. Go inside. Those angles. Co means together, interior means inside the parallel lines, co-U shape, right? This angle and that angle, armpit angles where it stinks. So when you add these two angles, because we have lines that are parallel, we should actually get 180. So B then added to 85. What is that angle? B should actually be what? So if we look at our options, is it A? Is it C? Is it D? All right. So that B, as you guys have said very beautifully, should be D, because 180 minus 85 gives us 95 degrees. So it's D, guys. Right, let's move on. 2.1.3. Then I update, just so I have that information. That's what I'm encouraging you to do. Okay, that's exactly what I'm saying to you. Fun X, but please understand first the F. Okay, on one side of the transversal line, bottom, we are equal. Top, we are equal. That's for F, corresponding angles. Co-interior, co-inside, the armpit angles. These are your two arms. They are straight in front of you. That's where your armpits are, where it stinks. The two angles added together are 180. You add roll-on, you add deodorant to those armpits so that it smells better. So you know the angles add up to 180, but there must be parallel lines, because inside them, that's where the angles added together add up to 180. Only between parallel lines, guys. All right? Then N, your Z shape, those two angles, we say they are equal. So it's F and Z, or N, that has equal angles. But for Z, it's alternate angles. For F, top, but it must be on the same side of the transversal line, guys. Okay, we don't say top, then top this side. We say top on the same side of the line. That's F. Okanye bottom, same side of the transversal line. That's the F. They are equal, those angles, as long as the lines are parallel. Then U, as I said, go inside the armpit angles. It stinks, you add 180. The two angles should add up to 180. But the lines must be parallel. This is not go inside these two, because these lines are not parallel. Are we together? Then the Z relationship. Z here, you saw most this one. We said this angle is equal to that angle. Z, those two angles are equal. But also if we had an angle here, it would be equal to that one. That's Z. You see? Z that's proper and Z that is not proper between parallel lines. All right. Then of course, as I said, X, this angle would be equal to that one for vertically opposite angle. This one equal to that one, this one equal to that one. This one equal to that one, this one equal to that one. This one equal to that one, this one equal to that one. That's the X. But it does not have to do with parallel lines, the X itself. So when you see parallel lines, think of fun, F-U-N, and check if there are any of those relationships. So 2.1.3 says angle A plus angle B. Now we have those two angles. What is angle A plus angle B equal to? If we look at our options there, okay, angle A is 70, angle B is 95. When you add those two angles, what do you get, guys? That's what they are asking here. Okay, it's C, guys, definitely. We get 165. You are correct. Okay, yeah. Then next one, 2.1.4. 2.1.4. X, where's X? X is equal. That's $1 million question. Okay, and so they want the angle. The option we have not chosen yet is probably going to be the answer, right? X is equal to, so let's go there. We have 2x minus 30. We have 70 degrees. These two have a relationship. These are angles that are on a what? They are on a straight line. 2x minus 30 plus 70 degrees. These are angles that are on a straight line. They share a common vertex. So if you take this angle from here to there and from there to here, remember we were told that 2P and VW are straight lines. So if this is a straight line, these two angles, they are adjacent or next to each other. We can say, you can see most this completes a protractor from 0 to 180. So we can say 2x minus 30 degrees is equal to 70 degrees. Why? Angles on a straight line. And then we can check what the value of x is. 2x is equal to, we take the 30, we minus there, we get the 40. Yeah, 2x minus 30 is equal to 7. 2x minus 30. Oh, why did I say? What nonsense is this that I'm writing? You guys are also not noticing the nonsense. 2x minus 30 plus 70 degrees is equal to 180. Okay, did you see this mistake that I made here? Okay, this is nonsense. Absolute rubbish. But I'm glad I made this nonsense. Okay, very, very bad. Don't ever do this nonsense. Say 2x minus 30 is equal. No. Okay, I'm not even writing what I had said about these two angles. I'm writing what I don't know. I don't know what in the world came over me. Okay, guys, please take note of what comes over you. You may have that problem as well when you're writing. Something comes over you, you write what you don't mean. So after writing, just check again if it is what you actually mean. Okay, now this makes sense. Angles on a straight line. 2x minus 30 plus 70 is equal to 180. Angles on a straight line. Then we can solve this. 70 is positive. When we take it over, it becomes negative. Negative 30 is negative, so when it goes over, it becomes positive. Then we have 110 plus 30, which is 140. 2x is equal to 140. Then what do we do from here? We divide both sides by the coefficient of x, which is 2. What we do on the left, we do on the right. So x is equal to 70 degrees. Okay, I'm gonna stop here and check. Are we together? Am I losing any of you? Okay, so we good. Yeah, so that's why we say x is 70. So this is A. Then lastly, B and C. Angle B, there's angle B. And angle C, there is angle C. What do you notice about this? One side of the transversal line on top of this, on top of that. Yes, Lifa, you are seeing the F shape corresponding angles. Yes. So our answer there for B and C, angle B and angle C they are what, guys? They are corresponding. So we choose who? I don't know these things in English. Sorry, I actually don't know these things in Afrikaans. I'm gonna have to self-teach myself Afrikaans so that I can appeal to my Afrikaans audience. I kind of sense that my Afrikaans audience, the learners, they are the ones that one day will just give me a galaxy here. So I need to actually learn my Afrikaans and get it up to speed, or like get my Afrikaans terms into gear. That is my New Year's resolution. Don't worry. I will appeal to you guys, okay? I'm sorry for now that I don't, but I'll definitely appeal to you. Give me this holiday. You'll see me next year when I'll be saying Driwuki yeah, Ian Walter. Yeah, just give me this holiday. I'll come back on another level, you know. So thank you so much, though. I really appreciate Snowman. Really appreciate the gift there. Warren Stiamandauka. Don't worry, you'll see me doing the things. I'm telling you, I'm gonna come back better. It's like it will be Maths is a Game 2.0 version 2.0. Zenenye, yeah, Pakati inside. Zenenye for sure. Alright, yes, this is paper 2, guys. Okay. Botlale, thank you, you're welcome. Njabulo, you're welcome. Yeah, we are here to learn, my leader. We are here to learn. 2.2. Sis, come on, guys, calm down. This is a natural phenomenon of life. When you have things, you cough. Choose the correct angle size from table A only once. Yeah, so that means only once. You can't choose the option from table A twice. I will post this on YouTube, Henrico Maritz, don't worry. To complete each statement in column B. This is my birthday gift to myself, to you guys. This live session that I'm doing is my birthday gift to you guys this morning. You know, first thing I do. My whole purpose of I feel like being alive is to help. So this is my birthday gift to you. To myself, simultaneous. Thank you so much. Really appreciate it. Thank you for the birthday wishes. Thank you. Table A only one. To complete each statement in column what? Column B. Write only the letter A, B, C, D, or E. This is both for grade 8 and grade 9, guys. Just because it says grade 9 here, that the knowledge is applicable to what? To grade 8 and 9 as well. My grade 10s who are here will also be very keen to be here because they know that these are the basics for them in their grade. The grade 11 learners that are writing maths paper 2, these are the basics for their maths that they are writing if they are writing paper 2 on Monday. So this is beneficial for all grades in high school. Grade 12 learner who is going to be rewriting, these are basics for them too. So this is good for them. Write only the letter A next to the statement. Two angles of an isosceles right-angled triangle are each. Yes, Pauline, I'll be posting this there. Thank you guys for the birthday wishes to everybody that's been so precious. Thank you so much. Babes, thank you so much. Tato, Carlos, Sia, the killer, Antlahang, Kabelo, Fabez, and the one and only. Thank you. Two angles of an isosceles triangles are each. Two angles of an isosceles right-angled triangle are each. Is it A? Is it B? Is it C? Is it D? Is it E? Now be careful. They are saying two angles of a what? An isosceles right-angled triangle. So picture it first. Picture it first. So the triangle is isosceles. it is right angled, which means we have an angle of 90 degrees. So these two angles, guys, will be equal to each other. If that is 90 plus these two angles, which will also be both 90 degrees, those two angles will be both adding up. They both add up to 90. Why do I know that? It's because this angle is 90. So if it's an isosceles triangle, then that means the remaining sum of angles is 90 degrees, but they are equal. So I'm going to say 90 degrees divided by 2, which gives me 45 degrees. So this is 45, 45. So look at the statement. The angles of an isosceles right-angled triangle are each. Okay. Now, by the fact that they are saying right-angled, that means one of the angles is already taken care of. But then the two that they are talking about, two that are remaining, what are the two angles each going to be? The two remaining angles are each going to be 45 degrees. Right-angled takes care of the one angle, that is 90. But since it's an isosceles triangle, it means the two sides will be opposite two equal angles, which are each what? 45 degrees. So our answer that we choose there is E. Please read into the statement first before choosing an option and make sure you understand what they are asking so that you choose the relevant option and not lose the marks that you are supposed to gain. Sis. 2.2.2. The sum of the interior angles of a triangle is equal to. The sum of the interior angles of a triangle is equal to A, 180, B, 60, C, 90, D, 360. We've already chosen E, so we're not going to be choosing it again because we are choosing only once from our options. There's no way we're going to be repeating the choice. So the sum of the interior angles of a triangle, we should all know this by now, guys. 180, so that means we are choosing A. Okay, thank you so much. 2.2.3. The sum of the interior angles of any quadrilateral, the sum of the interior angles of any quadrilateral is equal to. Okay, good guys, you know this, you know this, you know this. We should know this by now. 2.2.4. Two intersecting lines are perpendicular if they form an angle of. Two intersecting lines are perpendicular. Two lines intersecting is what we're talking about. One line intersecting another one, meaning it's cutting the other. And then we say they are perpendicular. If they are perpendicular, they form an angle. What is the angle formed here? This angle formed here. This angle formed here is 90. The angle formed here is 90. The angle formed here is 90. The angle formed there is 90. The two intersecting lines, if they form an angle of 90 degrees. So that means our option is C. And then lastly, each interior angle in an equilateral triangle, each one, one angle each in an equilateral triangle is equal to. Very good, guys, in the comment section. Definitely it is. Each individual angle is 60 degrees, so yes, it is B. Okay, this is a 2025 paper written in another province, in another district, which is called the Nelson Mandela Bay District, on the 5th of November. So yeah, it's this year's paper written in this province. Okay, it's a paper 2. Okay, we are done, guys. Very good, very well done. So we were able to get through the multiple choice and the multiple choice and the matching the columns questions very well. Okay, now here, guys, I'm not going to be doing any more deep explanation because in the multiple choice I've done a lot of deep explanation. Now we are going to simply go ahead and answer these questions. In the figure below, determine with reasons the size of x. So here they've given us statement column, they've given us reason column. These people were very nice and kind because they gave us the layout, all right, so that we can make sure that we write the things that will give us the marks. So Lifa Shelby is saying angles on a straight line. Okay, Z is saying x plus 90 plus 25 is equal to 180. I think that's a statement that we can definitely write. Thank you so much. X plus 90 plus 25 degrees is equal to 180 degrees. That's a statement that is true that we can write. What is the reason? As you have said, angles on a STR line. And from there, what do? We solve. X is equal to 180 minus 90 minus 25 degrees. Okay. X plus 90 plus 29. Thank you so much for sharing with me that I made a mistake there. Thank you. All right, so I'm very happy that you guys see that I made the mistake. Make sure that you also make it a point when you're writing these individual angles in your statement, because I tell you now, as I was marking my learners that were writing this paper, I found them many times writing angles just like I did just now. You know, you take for granted that, oh, okay, that angle is 25. Okay, imagine if I called you Carlos, but yet your name is Tato. That is painful, right? If I say to you Tato, and I'm like so adamant, Tato, but yet you are Carlos, so painful, hey? So painful. It's like you don't know me. So we must make sure that the angle that we know is what we write. You guys are correct. X is equal to 61 degrees. Indeed, it is 61 degrees. Okay. Ain't no way he'd teach us after exams, bro. The thing is, some of you have written in your respective regions or districts. Okay? And remember, why I use you as an example? Because you are amazing, Carlos. And I knew you wouldn't take it too personally. So, X is equal to 61 degrees. What grade am I teaching? I teach all grades, my leader. At the moment, we are doing a grade 9, but also relevant to grade 8 paper. Okay. Some of you would have done probably this a bit different. Okay, I see some people could have said x plus 29 degrees is equal to 90 degrees. Why? Complementary angles. Okay. Complementary angles. Someone else could have said x plus 29. They see the 90 degrees, the fact that this is perpendicular, and they know that if this is 90, this entire angle as well on this side is 90. So they say x plus 29 degrees is equal to 90 degrees, and they say complementary angles. What are complementary angles? Angles that add up to 90. So these two angles add up to 90. Still, same answer, guys. Same beautiful answer. Same beautiful answer, and that would have been very good. Thank you so much, Mez. That is so kind of you. 5 beautiful roses. I can smell the love. I'm just kidding. I smell the love, my. Thank you so much. I really appreciate it, though. Use the diagram below to find with the reasons. Sparkler, thank you. With the reasons, the value of x and y. I can smell the roses there. Use the diagram below to find with reasons the values of x and y. So first we look at the diagram. We have AB, it's a parallel line. We have CD, it's a parallel line. We have this line EF, which is a transversal line. Immediately we can see the relationship between 33 and x. So that should help us with getting the value of x, guys. So what is the value of x? Because on the same side of the transversal line, on top, we say these two angles are what type of angles? And what are they? Very good, guys. X is equal to 33 degrees. But please, when you write your reasons, corresponding angles, then after that, please, guys, don't just write corresponding angles alone. You must do what after writing corresponding angles? You must state the lines that are parallel. I repeat, indicate the lines that are parallel when you write corresponding angles. For any of the F, U, and N relationship, I beg you, write the lines that are parallel as part of your reasoning. It is not enough to simply say corresponding angles. These angles are corresponding whether the lines are parallel or not. They become equal to each other the moment there are lines that are parallel. I beg you to always state the lines that are parallel so that your full reason is watertight and is pleasing to me and pleasing to anyone who's marking your paper. Then, like your phone does updates, you update your diagram so that now you have 33. Compare now, what is the value of y? Your updated information, you indicate the answer for the next. Y is equal to what, guys? Y is equal to, very good, Sibate, 33 degrees as well. Why is y equal to 33 degrees, guys? Y is equal to 33 degrees for the reason that vert op angles, okay, vertically opposite angles, okay, and that's it. No parallel lines, because like I said, the whole inclusion of parallel lines is applicable for corresponding angles, co-interior angles, and alternate angles. You must state lines that are parallel. But for when angles are vertically opposite, thank you, Lians, for the hot me. When angles are vertically opposite, our x, this angle is equal to that one. That angle is equal to that one. That is for the x for vertically opposite. Okay. Okay. Then moving on to 3.3. In triangle ABC, angle B is 70, angle C is 30. Calculate the size of angle A with reasons. This is angle A, angle B, angle C. Calculate the size of angle A, right? So you guys see the answer, and Dimples is seeing the answer, as I hope most of you are seeing the answer, because what do we know about the angles of the triangle? We know what we know. So that means we are going to say angle A plus 70 degrees plus 30 degrees is equal to 180. Why? We can say sum of angles in triangle. Okay, then from there we transpose 180, take the 30 that's positive, negative 30, take the 70 that's positive, negative 70 on the other side. Then our answer for angle A is what? 80 degrees. Statement, reason, simplification to the answer. And that's it, right? Okay, hope we see that. And we can turn over to the next page. Okay. In the diagram below, angle CAB, remember I said the middle letter is referring to the angle. So you move with the letters CAB. That's 2x minus 48. It's in the diagram. We have it there. If this was not in the diagram, I would have gone ahead and written it down in the diagram so I can see it visually in my diagram. Angle ABC. What's angle ABC? The middle letter, x plus 14. There it is. BCE. Middle letter, BCE. This angle there is 116. They are saying calculate the value of x, give reasons for your answer. Now I'm sure you guys can see that there's a relationship between what we call here the exterior angle of this triangle. It should be equal to what? to the sum of the two interior opposite angles. These are two interior angles that whose sum, the addition of them, is equal to the exterior angle. This is the true exterior angle because it is in line with the side of the triangle. So AC extends to E, it is in line with the side of the triangle. This is an angle formed external to the triangle. These two angles, we call them the interior opposite angles, whose sum gives us 116. Not this angle and this angle sum give us 116. No. Not this angle and this angle sum gives us 116. No. It is always these two angles, as long as the angle that is outside, which is formed in line with the side of the triangle, is basically there. So our statement here can simply be 2x minus 48 degrees plus x plus 14 degrees is equal to 116. What's the reason? Exterior angle, triangle. 2x minus 48 degrees plus x plus 14 degrees, the sum of these two angles is equal to the exterior angle of the triangle. Doug, you are very rude on the live, coming here and basically saying what you are saying. Yeah, you are another person who I'm going to block because I don't like or appreciate rude people like that. 2x minus 48 plus x plus 14 is equal to 116. Exterior angle of a triangle. Thank you, Descano, for that, Rose, and thank you, Smash, as well. So these two angles, guys, I hope you now understand what I'm saying, that we can use the idea or the concept of exterior angle of a triangle because we know that the exterior angle is equal to the sum of the two interior opposite angles. Okay, I hope it makes sense. You're very welcome. Okay, very welcome. So we add these two. This guy we add to that guy, and please, guys, note if you have a triangle like this here, as I said, this is the true exterior. The sum of the two angles are these two. These two added together will give you that one. Listen to me here. This C1 is not an exterior angle whose sum is equal to these two. Why? Because, as I said to you, for it to be a true exterior, it must be in line with the side of the triangle. If it is not in line, it goes off in an angle, then this C1 is not equal to the sum of these two. That's very important. So please ensure that when you look at the diagram, it truly shows that the side is in line with the side of the triangle. Okay, so I hope you understand that the side of the triangle must be in line with that extension that basically gives you the exterior angle. These are the two interior opposite angles whose sum gives you that. It's these two, guys. It's not A and this one that gives you that one. It's not this one and this one that gives you that one. No, it's these two. Okay, I hope it makes sense. So we add these two, we get that, and we solve. Now 2x plus x, because 2x is positive and x is positive, we add together, we take all the numerical values, we transpose them. 14 becomes negative, negative 48 becomes positive. 2x plus x is 3x. Remember, when you add like terms, you keep the variable x. You add the what? The coefficients. This is 1. This is 2. You add 2 and 1 together, you get 3. You keep the variable x there. Okay, yeah, it's there, guys. The equal sign is there. It was there. It's just that I wrote it on the line. Fix the equals. Thank you. I can say some people are very, particular. Guys, I understand that some of you have written. Remember, I did live sessions for paper 2 already. For those people that had been writing that time, I did those for those at that time. Maybe it's because you are only seeing this now. There are people who are writing next week. That's why I'm doing the live lesson. There are people who are still writing paper 2 next week. Okay, Yeah, year 2. If you are saying please do paper 1, when are you writing paper 1? Okay, send me a message on the site, right? Inbox message me. Okay. Tinkerbell, I basically can't really say when, because if the time is open, I go live. If the time is closed, I don't. The first part, I'll be uploading the actual live session, guys, on my YouTube channel the minute I'm done with this session. Right? So you can go to the link in my bio. YouTube link is there. Maths is a Game is the YouTube channel. You can just go there to my link and then make sure that you subscribe so that you can check out what you missed. So what's 116 minus 14 plus 48, guys? Let's get it from you. 116 minus 14 plus 48. Now let's see who are the people who know their stuff, their maths. So when you subtract this, you get 59. The guy is saying I get 59. 116 minus 14 plus 48. Okay, so it seems like there's a consensus that it's 150. Then after that, we divide both sides by what? The coefficient of x, which is 3. So we get x is equal to what? 50 degrees. Okay. Okay. Now I have x. The next question says calculate the actual size of CAB. CAB, the actual size. So I need the actual size of CAB. Remember, CAB currently, the angle is in terms of x. CAB is in terms of x. 2x minus 48. We say that this angle CAB, this angle, 2x minus 48 degrees, is in terms of x. It is in what? It is in terms of x. What happened to 2x? Say D, what happened to 2x? Are you talking about this 2x? 2x plus this x together. When you add 2x and x, what do you get? Adding of like terms. You keep the variable x, you add the coefficient. What's 2 plus 1? It's 3. So that's where what happened to 2x is that it got added to 1x and it became 3x. Then we got 3x. Then 3 is multiplied to x. We divide both sides by 3. Alright? To get x is equal to 50 degrees. Now we want the actual size of angle CAB. You're welcome, Sedi. Angle CAB. This angle. So what you do is you're going to write 2x minus 48 and you are going to substitute this 50 degrees in the place of x. You got x most. So in the place of x, you substitute 50. Alright? In brackets. Then you subtract that 48 that is already there. And then you work out what this is. So what's 2 times 50? It's 100. What's 100 minus 48? So what is the actual angle size of angle CAB? What is the actual size? 2 times 50, which is 100 minus 48. What's 100 minus 48, guys? It is actually equal to, thank you, Sadie, 52 degrees. So this is the actual size of CAB. 52. 52. 52. Yes, I'm going to post it, no doubt. Where is the reasons? Remember, I don't need a reason here. The angle CAB is an angle that is there. It's 2x minus 48 degrees. I just found and calculated the value of x, which is 50 degrees, having used a reason to get to the angle x is equal to 50. Now, all they want is the size of angle CAB. So CAB currently is in terms of x. Alright? Now all I do is I substitute substitute that 50 degrees that I got in the place of x here. So I put it in brackets, minus the 48. Remember, when you're saying 2x, 2 and x have a relationship of multiply. So 2 times 50 gives you 100, minus 48 gives you 52 degrees. Yes, we are looking into angle A. Because guys, when they do this, CA, the cap is on top of A. The focus is on A. So we move with the letters C, A, B. The middle letter refers to the angle. So this is a kind of notation that they use to refer to an angle. You see? I just want to show you something else. This notation, still the same. Angle CAD. It's just that they put this symbol of angle here, but it still refers to the middle letter. So CAD, middle letter refers to the angle. All right. Okay. TMWS. Yes, it will be on YouTube, guys. I'll upload it when I'm done. TMWS is a what? Is a parallelogram. TMWS is a parallelogram. That means all the properties of a parallelogram will apply to this diagram. Calculate the values of x, of y, and of z with reasons. Maths is a Game is the YouTube handle. Link is in my bio. Link of the YouTube channel is in my bio. So calculate the values of x, y, and z. Okay. TMWS is a parallelogram. TMWS is a palm. Calculate the values of x, y, and z with reasons. So we are told that TMWS is a parallelogram. So that means all the properties of a parallelogram will apply to TMWS. There's other information that we've been given. For instance, there's this triangle here. These two sides are equal. All right, does that make sense? These two sides are equal. That means these angles will obviously be equal. We've been given a 60 degrees here. They want us to find x, they want us to find y, and they want us to find z with reasons. Okay, so let's first start with this x that is obviously in our face. So if these two sides, guys, are equal, all right, then let us first say angle C1 is also equal to who? To x. Angle C1 here is also equal to x. This C1 and this angle M are equal. So I'm going to have to update and say angle C1 is equal to x. The reason is angles opposite equal sides. That's my reason for saying angle C1 is equal to x. Okay. Then from there, I can say for that triangle, x plus x plus 60 degrees for this triangle CMW is equal to 180 degrees. What's the reason for saying that? The reason for saying that is sum of angles in a triangle. That's why. Okay, so I repeat, where did I start? I saw that this means these two sides are equal, and if these two sides are equal, it means that these angles are also equal. Okay, why? Angles opposite equal sides. Okay, then we can do what? We can say x plus that x plus 60 is equal to 180. Okay, Guys, just hang on here. I just need to do something very quickly. That's okay. I hope you guys understand what I did there. Okay, this is very important, guys. The thing is, with this thing of angles opposite equal sides for an isosceles triangle, it's something you guys need to also get used to. Okay, yeah, this is the 2025 November exam. It is one that was written in a particular district, so it was written on the 5th, right? Because remember, different districts and provinces write different papers. So I'm using this to sort of like, give others an opportunity to do a paper that was written. Okay, I don't ever do papers that are yet to be written because I don't have access to them. And even if I did, all right, even if I did, I would never do them in my life because I'm not a person who believes in cheating and doing all sorts. So I'll never do it for that reason. Okay, so now let's go and work this out. So we have 2x plus 60 degrees is equal to 180. All right, then we isolate. We take the 60 degrees over, we get 120 degrees. 180 minus 60 is 120. Then we divide both sides by what? By 2, so that we get x is equal to 60 degrees. Yeah, so x is 60. So I simply go and update my diagram so that I have those angles now present in my diagram, so that when I look at my updated diagram, that can possibly assist me with everything else that I need to still yet calculate. Yeah, I hope that makes sense, right? Very, very important. You update your diagram so that it can assist you with everything else that you are still yet to calculate. Okay, so remember guys, we were not told that this is an equilateral triangle. We were not told that. Okay, so we needed to use the given information, the fact that that is 60, we needed to use that to assist us in being able to, for instance, because these sides are equal, we know that angles that are opposite equal sides, they are also equal. So that's why we said angle C1 is equal to x, because it's equal to this angle M, angles opposite equal sides. I then put that x in there. Then since this is a triangle, I added my angles in a triangle, and I know the angles sum is 180. I gave my reason, solved for x, got x, right? And really and truly, very easy for them to give me my marks, very easy for them to give me my marks. My statement and my reason, 1 mark there. My statement, my reason, 1 additional mark, and then basically solving for x is my other mark. So I get 3 marks for finding the value of x. Right, and providing sufficient and adequate reasons. Then, Mapagati, how did we get 2, please? Mapagati, x plus x. When you have coefficients, when you have variables x, we call these like terms. So what we do is we add these like terms by doing what? We keep the variable when we are adding like terms. So the variable is x, it has the same exponent. So we keep that variable and we add the coefficients. By coefficients, I mean the numbers that are next to these letters. Okay, so there's an invisible 1 that is there. Okay, it's always there, just like God and the Holy Spirit are always there, angels and all of that stuff, present but never visible or seen with the naked eye. So we take the 1 and the 1, we add together, we get 2. And that's why it's 2x. Okay? So I hope that makes sense. The invisible 1. Yeah. The one who remains unseen. As long as the one who remains unseen has a physical representative like x, then basically he feels no need to show himself to the naked eye. So that's basically how I tend to remember that. So that's how I got the 2x. So then we solve for x and we get x is equal to 60. So x is equal to 60, like I said, you update your diagram. So that is 60, that is 60. This is for both grade 8 and 9. So we have 60, we have 60 there. Now we want to find y. Guys, remember they said this is a parallelogram. So that means all properties of a parallelogram will apply to this diagram. For a parallelogram, we know the following. We know that the opposite sides are parallel. Okay, that's one thing we know for a parallelogram. We also know that the opposite angles of a parallelogram are what? They are equal. That's something you know. That the opposite angles of a parallelogram are what? Are equal. So you know what the value of this angle is. That means this angle and those 2 angles, the sum of them, they are both equal. So I can say the following. Y plus y is equal to 60 degrees. This angle plus this angle together is equal to 60 degrees, that entire angle. Why am I saying that? Opposite angles of parallelogram. Opposite angles. This symbol here means parallelogram. I know some people use palm for short. Whether you write this symbol or that symbol, I do believe that in grade 9 it's fine. But why am I writing opposite angles of a parallelogram? It's because I understand that angle S, the entire angle, which is y plus y together, plus angle M, which means this entire angle, which is 60 degrees. And thank goodness I updated my diagram, because I can see the relationship that exists between this angle and that angle. Where is this coming from? The fact that they said TMWS is a parallelogram. It means all the properties of a parallelogram apply to this diagram. Alright? So now it means I can actually say y plus y is equal to 60 degrees. The reason? Opposite angles of a parallelogram. Now I can solve for y. Okay, Dr. Hardy 37, can I ask, why are you saying it's wrong? Please provide your reasoning in the comment section. If not, if you are simply here to be a detractor, I ask you kindly to leave the live because you are being problematic. Okay, you are being problematic. Yeah, it's unfortunate that you would just throw a random statement like that and say it's wrong, but you do not provide. If you are here to distract, please kindly leave the live. Okay, you are not appreciated. Throwing baseless comments in the comment section just for, I don't know, for clicks, or I don't know, for attention, or for what. Okay, or I will block you kindly. I will block you kindly. Okay, y plus y is equal to 60 degrees. So the two we add together, y plus y. Okay, so for those who might be wondering, why do we say y plus y? Remember, guys, we said this entire angle S is the summation of these two angles. So y plus y is 2y. And remember, this goes back to the coefficient of y that I said, whether we're adding like terms, we keep the variable, we add the coefficients. All right, I think Dr. Hardy, let's get rid of you. Yeah, I think some people want followers and stuff, but they do it in a way that's just, yeah, I don't really appreciate. Y plus y is 2y. That's equal to 60 degrees. Then, what do we do from here? We divide both sides by 2, the coefficient of y, which gives us our y value, which is 30 degrees. Okay, so you guys are 100% spot on. And that's why. Then we go and update 30, 30. Okay, as simple as that. We go and update 30, 30. Right. The next thing we pleasingly need is the value of z. We have that. We have these 3 angles, and we need this angle now, z. And z is situated within a triangle. Okay. Yeah. Okay. So for instance, W1 we can find, so that we can use this triangle CSW. So angle W1 we can find. There's 2 ways of finding angle W1 depending on who you are. Yes, CODM. The opposite angles of a parallelogram are always equal. Okay? They are always equal. I hope that makes sense, and now you actually are internalizing something. It's very important. Okay? So we can find angle W1. Okay? There's a relationship of this angle with these 2 angles. For the U shape, remember these lines are parallel. So these 2 angles are co-interior, these ones. So you can find W1 using co-interior angles. Or you can look at this C1 and W1. Do you see angle C1 and angle W1? You already know what C1 is. You updated your angle there. Angle C1 is equal to, and therefore you can find angle W1. Does that make sense, guys? Yeah, and remember, if you are going to say CW something, then you are going to say it's CWS, not CWM. It is CWS. There you go. Very important. Okay. So, no, W1 is alternate to C1, not vertically opposite. CW1. Remember, guys, this is the Z shape. The Z shape. Remember our Z shape for N? That Z shape. Okay. But the lines must be parallel, remember? So this is alternate. Okay. So you can either use co-interior angles. You'll find W1, it's the same answer. Or you can use what? You can use co-interior, or you can use alternate. But alternate is more fast. Angle W1 is equal to C1, which is equal to 60 degrees. What's the reason? Alt angles. Then you must state the lines that are parallel. Please don't forget to state the lines that are parallel. TM is parallel to SW. TM is parallel to SW. Angle C1 is equal to W1. Hopefully that makes sense. Okay. Okay, let's check what is someone saying. Can C2, now remember guys, we don't have C2. We don't have C2. Here we have angle C1. All right. Okay, please ask all the questions that you need so that we can clarify any misconceptions you have. Okay, so we can either say this is not C2 guys, this is the letter Z. We want the letter Z. All right, so remember, if you are not given, okay, SCW, yes, so you are saying SCW, what about SCW? Can you say SCW is equal to CWM? No. We can't say that SCW, we can't say this angle is equal to that one. Why? Because I know some of you are thinking of, but sir, this is a Z relationship. Yes, this is Z. These are angles that are in that position of Z, but the question is this line and that line parallel? No, this line is not parallel to that one. So they are angles that we call alternate. They are alternating angles, but we do not have lines that are parallel, so therefore we can't say this angle is equal to that one. You see now, that's why when you write your reason, we include lines that are parallel. I said what makes alternate angles alternate, what makes alternate angles equal is the fact that we have lines that are parallel. So we can't say that this angle is equal to that one. Okay, does that make sense? Because SC is not parallel to WM. It's not. So we can't say these two angles are equal. Okay, so I hope it makes sense. So thank you for actually asking that question, because when I was marking my learners that were writing this paper, I found that most of them had the misconception of thinking that this angle is equal to that one, and they all said alternate angles. Guys, yes, the angles, this one and that one, they are alternate in the meaning of what alternate means. The word alternate does mean that angle and that angle, whether the lines are parallel or not. But remember, alternate angles become equal the minute you have lines that are parallel. That's when those angles become equal. Okay, don't worry, you'll find the video on the YouTube channel, okay, so that you can follow along what you missed. Don't worry. So please guys, do go and check out the YouTube channel. SCW, can we say angles of a triangle should equal to 180? Now, since we found that this angle C1 is equal to angle W1, and we said they are equal to 60, now we can go ahead and use the triangle, sum of angles in a triangle, and find Z. You see? Now we can do that. That's fine. That's 100% correct. So we are going to say Z plus 30 plus 60 degrees is equal to 180 degrees. Why? Sum of angles in triangle. That's all. Okay. That's it. What do you want? Yeah, okay. Then we can transpose minus 60, yes, CODM. We get Z is equal to 90 degrees, and that's our answer. Right? How many marks? Look, 7, guys. 7 marks for all this. For all this. For all of this. 7 marks. Okay. All right, that's that. And that was step by step how we were able to maneuver through this paper. ABCD is a quadrilateral. Determine with reasons the size of X. These are 4 easy marks, guys. Everybody should get this one. You tell me, what do we do? Yeah. If I have not taught you anything in this live, then this one will also be a pain. But really, you guys should be able to do this one sleeping. Ink FFX, chill, don't worry. Okay, and all those people that are saying we've written, I know you've written. You are telling me that you have. But remember, some people have not written paper 2. They are going to only be writing next week, grade 9. So don't tell me something. I already know what you are telling me. Chill like a pill. Thank you so much for those who are following very beautifully there. I appreciate the followers. I really appreciate it. Can you have all my attention? If you want all my attention, then you have to actually, yeah. Oh, thank you so much, guys, for the gifts. I really appreciate it. Thank you, Aplex Ludada. Thank you for that. Okay, Lifa Shelby kicked off the statements there and said x plus 4x plus 3x plus 2x is equal to 360 degrees. Very true. What would be the reason? What is the reason? Okay, because you're right. We add all the angles together, equal to 360. What's the reason? Okay, let's make sure we also write, yeah, sum of angles in a quadrilateral. Thank you, Spamadambo, for yes, sum of angles in a quadrilateral. That's fine. Okay, when you write these, just confirm there's an x, there's the 4x, there's the 3x, there's the 2x. Make sure you write correctly. Or interior angles of a quad, that's also fine. 7 plus 2, 10x. 1 plus 4 is 5, 5 plus 3 is 8, 8 plus 2 is 10. Then the variable stays the same. Divide by 10 both sides. If you divide by 10 both sides, you get x is equal to 36. Okay, let's just do it. Because I feel like some people will be like, where did you get this from? Where did you get that from? So let's see it. Yeah. Okay, that was straightforward. Easy 4 marks. Easy 4 marks. Easy. Easy. Answer the following questions. Now we're entering into congruence and similarity. Answer the following questions that relate to congruency in the figure below. Prove that triangle KLM is congruent to triangle KNM. Okay, remember congruency for 2 triangles. How many cases do we have of congruency? 1, 2, 3, 4. Or sometimes, right, depending on the situation. There's 4 cases of congruency. So what are we seeing here? SSS, but we need to provide statements and reasons. So our first statement here will be what? I'm sure you can see. This is triangle KLM, KLM, KNM, KNM. So let's provide statements and reasons. What do we say? KL is equal to KN. Bartina, I agree with you. KN is equal to KL. We need a reason. What do we say as our reason? Queen Celine and Bartina said KN is equal to KL, and they are 100% correct. I need a reason. Thank you, Queen. It is given. It is given. Guys, we were not told that this is a kite. We just need to provide reasons as per what we see. They are giving us that information. It would have been a different story if they had said the figure below is a kite. and then they didn't provide any of these symbols in there, they just gave us this diagram, then we would have been able to say Kn is equal to Kl and then talk about the sides of a kite. All right, so this is my first S, by the way. I like doing this on the side just so that I know what I'm talking about. Next, Mandela is saying Km is common, or someone else could say Km is equal to Km. All right, which means the reason we have a common side. Km is a common side for triangle KML and for triangle KMN. This is a side that is equal for both. So we can say Km for this triangle is equal to Km for this triangle because it is one side that is common. So that's my second S. What's the last statement, guys? The last and final and concluding statement that I can write with my reason there. Lm is equal to, no, Lm is not equal to Lm. Claire, Nm is equal to Lm. Thank you, Claire, with your statement and reason there. Nm is equal to Lm. Thank you, Claire. Given my third S. Then I simply go back here and I write things as you see them there. Triangle KLM is congruent. You see, I'm done with my case. Triangle KLM is congruent to triangle KNM. You write it as you see it there. This is what you needed to prove. Now you've proved it. So you conclude with it. And then you state the case. S, S, S. That's what you identified. Side, side, side. And guys, if you don't write this concluding statement, you don't get your final mark. Okay? So please, statement and reason 1 mark, statement and reason 1 mark, statement and reason the other mark, and then concluding statement and reason the final mark. Right? Don't worry, I will upload, I will share the paper, I'll take pictures when I'm done. So you'll have the paper there so that you can practice on your own. Right? Give 3 other conditions of congruency. Right? So we've just come from a question where we saw SSS in play. This pair of equal side was my first S. This second pair of equal side was my second S. This pair of equal sides was my third S. So that is the SSS. This side, that side, that side. The 3 pairs of sides that I proved are equal. That's why I have SSS. Now they are saying 3 other. They don't want this one. They want the other ones. Not this one. This one is the one that you just proved. So you can't be writing this one here because they are saying 3 other. English, guys. English is a language. And this is other, meaning other ones. Not this one. So you are going to write, as Claire is writing in the comment section, SAS. You can write SSA. SSA can also be written as AAS depending on... No. Sorry. SAS. That's correct. SSA. No, Claire. SSA is not a condition of congruency. This is the only condition of congruency that involves 2 sides and 1 angle. The angle must always be in the middle. So SSA is not a condition. RHS, yes, that is. Okay. So these 2, but we need one last one. We need one last one. Thank you, Batina. SAA. It's like South African Airways. SAA can also be written as AS. That's also fine. Remember, those people who are saying they are done, you are done. Others are not. That's enough. You are done, but others are not. Why would I be doing a live after the exams? Okay, I must have a reason. Okay, you are done, but others are not. And those who are not are interested in being here. But I don't encourage you to be here if you don't want to be here. given, okay, so those are the 3 marks, guys. Okay, given QR is parallel to NP, use the triangles in the diagram below to answer the following. QR is parallel to NP. Thank you, Aplex. Wow, I love your attitude there, Aplex. Then therefore, Aplex, I hope you will be part of my group of learners that will be doing the early grade 10 preparation. Hopefully you'll be part of my group of learners that will be doing the early grade 10 preparation for next year, if you are in grade 9, that is. Okay, because I'll be having sessions for early grade 10 preparation for mathematics for next year. But if you want to be part of that, please do send me a message on the side, because you need to actually go via your parent, okay, because there will be a fee attached to it, you know, for assisting those learners in that. And guys, the fee is reasonable, it's not ridiculous, but remember at the same time, you know, it is to help you so that you can get on right footing the minute you start the grade next year, and it's not even a pain. Use the triangles in the diagram below to answer the following. QR is parallel to NP. Okay, QR is parallel to NP. Okay, remember, those who missed, you will always check out the YouTube page. You can rewatch the session there. Then they are saying angle Q is equal to angle N. Does that make sense, that angle Q is equal to angle N? If I had asked you to provide a reason, what would you say is the reason that angle Q is equal to angle N? Because they are saying it is equal, but I'm just wondering, what would you say is the reason? Thank you, Remo. Very good. Very good. But remember, guys, you would give me the reason full, in the sense that you would tell me that it's alt angles, and then you'd state the lines that are parallel, guys. Please, QR is parallel to NP. Okay, don't forget to include the lines that are parallel. Now they are saying also angle R. What is angle R going to be equal to? You need to write the missing angle. Angle R is equal to angle what, guys? Lifa says P, Coco says P, Mr. Nonchalant says P, Claire says P, my anxiety says P. So yes, you guys are right. Angle R is equal to angle P. Don't forget the cap on top of the P. And if you were to provide a reason, why would you say angle R is equal to angle P? Why is this angle equal to that one? So hopefully you understand it's for the very same reason you provide your lines that are parallel, please. Then lastly, angle M1 is equal to what? This angle here is equal to which angle? No. Ntumbu M, you'll be wrong if you say it is given. It is not given. In the diagram, it's not given that the angles are equal. In the diagram, you have to identify the angles that are equal for angle R and P, and then the reason would be alt angles. QR is parallel to NP. It's not given to you. Please, guys. When things are given to you, you can see they are. You see, for instance, we can say here KM is equal to KL. Look at this. This and that mean they are equal. It's given. But when it's not given to you, you must provide a reason that is sensible. So yes, you guys are right. Angle M1 is equal to angle M2. If you were to provide a reason, you would say vert op angles equal. Right? Very true. Okay, love it. Now, concluding statement. Triangle QMR. QMR is what? What does this symbol stand for? Yes, bow tie method. Very good. I love some of you bow tie. Very good. Bow tie, vertically opposite. I love that. Okay. I love the X bow tie. Yes, sold out. This means similar. This is a symbol that means similar. 3 lines that are horizontal, that means congruent. 3 lines that are vertical, that means similar. So what is triangle QMR similar to? Okay. QMR. QMR is similar to triangle? Or omnibus? Yeah. Definitely omnibus. What do you think? Maths omnibus. QMR. Now look at the same letters. Is similar to triangle. If you start with Q, you must start with N, the angle that is equal. N, Q and N are equal. M, and then R. So it's NMP. Q equal to N, M equal to M, R equal to P. The order is important, with the vertices written in the correct order. If you don't write the vertices written in the correct order, then this would basically be wrong. So N with Q, M with the other M, and R with P. The order, guys. First is equal to first, second is equal to second, and third is equal to third. For reasons that you've provided, of course. Please, guys, what's the reason for similarity? It's not proportion. What did you use? You used one angle, two angle, three angles. Three pairs of angles equal that are corresponding. So it's A. It can't be corresponding sides in proportion. It has to be A because we used angle as a condition to prove what? Similarity. Right? Remember I said to you guys when we were doing the multiple choice that for similarity to be true, you can either prove that the angles that are corresponding are equiangular or that the sides are in the same proportion. Unfortunately here we can't use sides in the same proportion to prove similarity. Why? Because we don't have all three sides provided. Alright, so we can't use that as a condition. But for angles we can definitely do that for this diagram. For similarity to be proved with proportional sides, you need to have all three sides for the respective triangles available for you. Let's go to 5.2.3. 5.2.3. Determine the length of Q. Determine the length of who? Of Q. Now what's nice, guys, is that when the order is correct of triangles here, I just want to show you something. QMR NMP. QM and NM. In other words, QM over NM. Now we are using the idea of sides being in proportion. Why? Because we've proven that the triangles are similar. So if the triangles are similar, then the sides are actually in the same proportion. So my first eyebrow, QM over NM, that's actually equal to what? My second eyebrow, MR over MP. MR over MP. If the order was incorrect, then I would have had a problem with this. The order must be correct for us to have this. CODM, please, if you go to the link in my bio, it's called Maths is a Game. If you can't click on the link in my bio and it sends you directly to the YouTube channel, you can copy the link in my bio, paste it on your Google search engine, then press search. You'll be able to find the YouTube channel. The profile picture of my YouTube channel has a white background with a black Maths is a Game inscription of letters. You should be able to find it. So QM over NM is equal to MR over MP in that order, which is also equal to QR over NP, the smile. So it's my two eyebrows, first pair, second pair, third pair, MR over MP. Why is this true? Because triangles, because of what? of similar triangles. I just proved that the two triangles are similar. Therefore, the sides are in the same proportion. Now, I'm interested where MR is because that is my Q value. Okay, let's just look at this again, that everything is fine. QM over NM, okay. MR over MP, that's fine. QR, look at that error. QR, Q and R over NP. Hey, you see this nonsense? Yeah, and I make the error, guys. I make the error. I'm given the letters, I see what they are, but then I write rubbish here. QM over NM is equal to MR over MP is equal to QR over NP. Now from this, I'm going to choose two ratios, just two fractions. Why choose two? Because I only need two to solve for my Q, which is MR. So I'm going to first go to the fraction that has MR. This one is definitely coming down with me. Then let's check, does 2m and nm have values here? QM has 21, NM has 7. Then I can definitely take this fraction as well and deal with these two and just forget about this one. All right, which is what? QR. Where's QR? QR and what? And PN. All right, I could have used these two if I wanted to, or I could have used those two, but I'm deciding not to. I'm going to use these two. All right, so let's go and write QM. QM is 21. What is NM? NM, where's NM? NM is 7, which is equal to what? MR. Now MR is the Q that I'm looking for. And then MP, where's MP? MP is 5. Okay. Then I'm going to solve for Q. What's 21 divided by 7? It's 3. Then I want the value of what? Of Q. But there's a 5 that is divided. So I'm going to multiply by 5 over 1. What I call the inverse, the multiplicative inverse of division by 5 is I multiply. This is like 1 over 5. So I multiply by the multiplicative inverse, which is 5 over 1. But what I do on the left, I need to do where? On the right. Then that cancels. I'm left with Q, which is equal to what? What's 5 times 3? It is 15. So basically Q is equal to what? To 15. Okay. Don't worry, I'll post this paper. I will post even the YouTube video on my YouTube channel for those that came late. No problem. Okay. So we used similar triangles and the proportionality understanding that we have, that when triangles are similar, the sides can be written in the same proportion. Remember, first eyebrow over the first eyebrow, QM over NM. Second eyebrow over the second eyebrow, MR over MP. Smile over smile, QR over NP. What's the reason? It's because of similar triangles. I proved the similarity of the triangles. That is why I write these ratios. And out of the 3 ratios, I choose two of them, including the ratio that has the Q that I'm looking for. And they say determine the length of Q in what? In centimeters, which means I need to write my final answer in centimeters. Very important. I subscribe to what has been asked. So therefore, I then take the 2 fractions, this one and that one. They can work because I checked. Do I have QM? Yes, I do. Do I have NM? QM is 21. Do I have NM? NM is 7. Equal to MR, that's 2, over MP, which is 5. and you can solve for Q. Very happy you wrote well, aka blessing. I'm very happy. Okay, let's move on to the question 6. Question 6. Now this has to do with transformation geometry. The image of ABC is shown on the system, axis system below. Answer the questions. So here's the axis system, Y and x-axis. This is triangle ABC. And the first question is write down the coordinates of A, of B, and of C. The coordinates of what? Of A, of B, and of C. We need to write them down. So let's just come close and check. What would be the coordinates of A? In the comment section, guys, you can go ahead and tell me. A is equal to, X will be -4, yes, Claire, and Y will be 3. This point there of A, here, there, X is -4, whilst Y is +3. So very true. X is -4, Y is 3. What about B? The coordinates of B. What is the value of X? And what is the value of Y? So B, the coordinates. Yes, B is -2 and +2. Very good. Then lastly, what are the coordinates of C? X is -4, whilst Y is +1. Yes, this can help IEP as well. -4 and 1. Though I don't know the specifics of your paper, maybe you can drop me a message on my inbox, and then maybe I'll see if I can't do an IEP specific paper so I can help you out. So your A there, as you guys have said, -4 and 3. Our B is -2 and 2, and then our C is what? Is -4 and 1. Those are the coordinates of A, B, and C. Now, let's move on. The next question says, the image on the above grid moves. So this image here moves or translates 5 units to the right and 2 units up. Give the general rule for the transformation. Give the general rule for the transformation. I will post this on YouTube, don't worry. Give the general rule for the transformation, or I may have already posted it up actually. Give the general rule for the transformation. I mean the paper, that is. In my shorts video, maybe it's there. But the video itself, I'll post up the actual live video that I just did, so don't worry. So what's the general rule for the transformation? 5 units to the right. Which variable does this 5 units affect? Does it affect X or does it affect Y? And when we say to the right, are we adding 5 or are we subtracting Y? Because that's where our general rule will actually be interpreted. So we have X here. What are we doing to this X if we are saying we are moving 5 units to the right? All right, what does that entail? So yes, you guys are correct that to the right means we are affecting X, and Inc FFX says we add, so the rule is X plus 5. Okay, yeah, so it's X plus 5. And then here for Y we are saying 2 units up. So how are we affecting Y if we are saying 2 units up? 2 units up. Up means, do we add or subtract? We add, guys. Up means we add. Hopefully when you go up in your marks, you're not subtracting marks, guys. That would be painful, hey? But anyways, up the y-axis means we are adding y values, guys. So that means y plus 2. This would be the rule. Okay, so this would be the rule that we use for the transformation of 5 units to the right. We add to x. 2 units up, we add 2 to y. Had this been left, then obviously we would have subtracted 5. Had this been down, then we would have subtracted 2. So let's note, guys, for the benefit of the rule, what do we do? No, guys, for the rule, the general rule, what happened to x if we are saying 5 units to the right? We are adding 5 to x. What happened to y if we are saying 2 units up? We added 2 to y. So this is the rule. This is how we write the general rule. We don't write the general rule in any other way, given that we are given x and y. Let's say they had said p and q, then they had asked for the general rule. Then we would have said p plus 5 and q plus 2. Generally speaking. Now let's move on. Write down the what? The translated coordinates. So you guys will remember that for our diagram, you had told me what A, B, and C were. Let's just remind ourselves. You said A is negative 4 and 3, B is negative 2 and 2, and C is negative 4 and 1. So we said negative 4 and 3, negative 2 and 2, negative 4 and 1. Okay, so after translation, remember what did we say? There is the symbol to indicate that something will have happened. We do what to negative 4? We said we add 5. So what's negative 4 plus 5? Because we want to write down the image of the new coordinates. Because we want to write down the translated coordinates. Translated according to what? According to this rule. The grid moves 5 units to the right and 2 units up. The rule is this. So if we are saying plus 5 to our x value and saying plus 2 to our y values, what are the new coordinates for A, B, and C? Right. So here are the A value. The changed after the translation of 5 units up will be negative 4 plus 5. You guys said it, it's 1. Then we do the same thing to our x value for B. We add 5. So let's just write down the x values, and then after that we'll write down the y values. We add 5 to negative 2. We get what as our x coordinate for B? Okay, we get 3. And then we do the same thing for our last, because remember guys, this is negative 2 plus 5. Some of you are going to butcher this because you can't add integers. Negative 2 plus 5, guys, that is 3. If you don't know and you still make a mistake, write down or calculate, okay? Then last but not least, what about C? We add 5 to negative 4. We get what? 1. Let's move on now to the y values so that we can make life very easy. We're going to do the same thing. We are going to add 2, add 2, add 2. If you add 2 here, what do you get? You add 2 there, what do you get? You add 2 there, what do you get? So we get 5, we get 4, we get 3. Okay, and those are our coordinates. It's 3 simple basic marks, guys, that we get. Okay, simple. Okay, let's move on to here now. Draw the translated image on the above grid with the coordinates obtained in 6.2.2. Draw the what? The translated image on the what? On the grid that we just had there with the what? With the coordinates obtained in question 6.2.2. So now we need to go to our diagram and go draw what we have gotten as these points. We go back to that, okay? So that should not be too difficult. So we need to first identify A, which is 1 and 5. So 1 and 5. A, that is 1 and 5. So X, which is 1, is here. Y, which is 5, okay, is there. So this is where the two meet. That's the new A value, the A that is changed. So we put that apostrophe to the A to indicate that. Then the next pair of coordinates are 3 and 4. So X, that is 3. X, that is 3, is all the way on this line. Y, which is 4. So X, that is 3, and Y, which is 4. You see, that's where we are meeting here. That's my new B. And then last but not least, 1 and 3. X, which is 1, Y, which is 3. That's here. X, that is 1, Y, that is 3. We meet there. X all the way on this vertical line is X. Guys, everywhere on this vertical line, that's 1. X, that is 1. Everywhere on this horizontal line, that is Y, that is 3. So that is there. So C is there. And then all you do is you connect your beautiful what? And then you go ahead and you do the shading, because we are still talking about the same shaded shape, if you want to call it that. All right, you'd use pencil. Still talking about the same shaded shape. It's just that it's moved 5 units to the what? To the right, then 2 units up. So that's where it would end up being, and that would be our diagram. And that should be, yes, basically on the y-axis above this line, above the x-axis. All y values here are positive. Then the y values below the x-axis are negative. Okay, the x values on the right, on the left side of the y-axis are negative. These are x values that are negative, and then the x values on this side are positive. So we know that our Cartesian plane is divided into quadrants. This is the first quadrant, the second quadrant, the third quadrant, and this is the fourth quadrant. So we have 1, 2, 3, 4 quadrants in total that basically have pairs of coordinates. Your x values here are positive whilst your y are positive. Here in this quadrant, your x values here are negative whilst your y values are positive. Here in this quadrant, your x values are negative whilst your y are negative. And here your x values are positive whilst your y values are negative. So that's how you basically orientate yourself around this Cartesian plane. The y-axis, this is everywhere where x is 0. And then your x-axis is everywhere where your y is 0. Let's move on now to the next question. Draw the image below in the correct position on the given axis system. Reflect the object across the y-axis. Reflect the object where? Across the y-axis. So, if you look at the reflection across this line, this object is going to be looking directly back at itself. It's like you are seeing, it's like when you look at yourself in the mirror, you are standing here, you look yourself into the mirror, you are seeing the same person looking back at you, right? So for instance, this L is going to stay this L, because when we are reflecting across the y-axis, what happens? X changes signs, but y remains the same. I repeat, when we are reflecting across the y-axis, X changes sign. So your X coordinate will change sign. So if it was positive, it becomes negative. If it was negative, it becomes positive. That's what happens to X. But Y remains. Nothing happens to Y when you are reflecting across the what? The Y-axis. All right? All right, I hope that makes sense. Now, look at this L value. I know the Y value here is 0 on this. Sorry, the X value here is 0. All right, now 0 is a neutral number. It is 0. It's neither positive or negative. Okay, so the X value is going to stay. So the new image is going to have that same what? That same Y value. So the Y value will remain the same. The X is supposed to change, but X is 0, so 0 remains 0. Okay, yeah, so it's still there. L still remains there, no change. What about H? H, for our Y value will be the same. So the same Y value here will be the same Y value there. So how many units to the right? 1, 2. So that means X is still going to be, here X is -2, but here change the X value from -2 here, it will become +2. So I'm going to be interested in 1, 2, +2 here, whereas X here was -2. So X really has changed. Does that make sense? But Y, the Y value, it's still the same Y value. We are on the same horizontal line. So H that has changed is going to be here. All right, let's come here to Q. We are going to be on the same line still. Let's count from the y-axis. We have 1, 2. That's 2 that is positive. So which means this side I'm going to have what? 2 that is negative. So this side I'm going to have 2 that is positive. 1, 2. My Q is here, the one that has changed. Then I'm going down to P. This P here, 1, 2, 3. It's 3. 3 that is positive for X is going to change to 3 that is, 3 that is negative is going to change from 3 that is positive. So I'm going to count 1, 2, 3. P is here, that has changed, right? Then I'm just going to simply do this, do that, do this, and then take that straight line, take my ruler. Please guys, I don't have a ruler on me and I'm using my other hand to hold on to my phone. You get the point. That's that. So this same diagram, okay, L, H, Q, P is reflected mirror image of this diagram pointing to it this side. We are looking at each other over this mirror. We are looking at each other over this mirror. And because we are reflecting on the y-axis, X is changing whilst Y remains the same. The reason here the X value is still 0 is because if you are going to say, I'm going to change the sign of 0, 0 remains the same, guys. 0 is 0. 0 is neither positive or negative. So whether you multiply 0 by negative or you multiply 0 by positive, it remains as 0. That's why that L change point is still there. But everything else, you see, same horizontal line for Y, but X has changed. Same horizontal line for Y, but X has changed. It's no longer negative, but it's positive. Same horizontal line for P, but X has changed from negative to positive, negative to positive, negative to positive, but Y stayed the same because Y horizontal line is Y, vertical line is X. I hope it makes sense, guys. Okay, our X values we regard vertical, but our Y values we regard on the horizontal. So Hopefully that makes sense to all of you. And that is how you would get your marks, and that diagram would be drawn. Reflect across the y-axis. Had they said reflect across the x-axis, of course now we would look at it in the opposite way. Reflection on the x-axis means it is y that changes, whilst x is the one that stays the same. Okay? Here it's important to understand the concept more than anything else. Now these questions, the learners actually said, hey, sir, this one was a bit difficult. All right. Yeah, as I said, Melo, reflection, let me just explain this. Reflection in the x-axis. Remember, the x-axis is basically the line y is equal to 0. Okay, so don't let them trick you, because sometimes they say reflection in the line y is equal to 0. Some people don't know the line where y is equal to 0 is actually the x-axis. So what do we say is the rule here? We are saying when we are reflecting in the x-axis, who changes? Y changes. X stays same. Okay. This reflection in the x-axis. Was reflection in y-axis, as you saw, okay, which is also the y-axis is the line x is equal to 0. So sometimes they can say reflection in the line x is equal to 0, and then learners get put off. They're like, huh? So it didn't teach me anything about reflection in the line x is equal to 0. Was reflection in the line x is equal to 0 simply means reflection in the y-axis. That means x changes, as you saw in the diagram, but y stays same. Then there's the third type of reflection, which is reflection in the line y is equal to x. Here, with that reflection, you simply swap the coordinates. What do we mean by swap the coordinates? X becomes y and y becomes x. So you simply swap them around if they talk about reflection in the line y is equal to x. Okay, you swap the coordinates around. So I hope that in summary sort of like, you know, makes you know what do they mean. And when you see the object, you are seeing the object reflecting along that specific line. All right, a mirror image of the other, you know, the one looking at the other. That's important, that reflection, because even yourself, when you look at the mirror reflection of yourself in the water or in the mirror, what are you seeing? You are seeing yourself in that mirror, you know, and you are doing the exact same thing that you are doing, but whilst looking at yourself. Does that make sense? Yeah. So here you are looking at yourself with the x-axis being the reference of the mirror. Here you are looking at yourself with the y-axis being the reference, this side and that side, you see. And then along the line y is equal to x, you know, it's kind of like the line that cuts through the origin, you know. If you have the x and the y-axis, the line y is equal to x is basically the line that is moving in this direction. So you'll have a mirror image of something on this side and that side, a mirror image of the other, you see. That's what we mean by reflection in the line y is equal to x. So yeah, just for your information. Okay, now let's come here. Theorem of Pythagoras applied here. Theorem of Pythagoras says this: the square of the hypotenuse is equal to sum of the square of the other two sides. Triangle DF is an isosceles triangle. EF is equal to 18, D is equal to DF, which is equal to 12. Now they are saying calculate the perpendicular height from EF to D. So roughly draw a sketch as a demonstration. So what are they saying? Triangle DF is an isosceles triangle with what? With EF 18 and DE is equal to DF. So first, it's very important to first sort of like have that triangle that they are talking about. You can sketch it. Triangle what? DEF. Then they are saying EF is 18 centimeters. And apparently DE and DF are equal. They are both 12 centimeters. Now, they are saying here, calculate the what? Okay, perpendicular height. Now, from here, they had said nothing about the triangle being right angle, nothing at all. So this triangle DEF is triangle DEF as it is, all right? It's isosceles. That's all we know so far. Now, in this statement, they're saying calculate the perpendicular height from where? From EF to D. The perpendicular height from where? From EF. Where is from EF? EF to what? To D. EF to D. What do they want? The perpendicular height. From what? From EF all the way to D. That's what they mean. What do they want? They want the perpendicular height. They want you and I to calculate the perpendicular height. From what? From EF to D. Okay, so I want us to reread this thing again and check if my diagram, is it fine or is there something seriously wrong with what I've done? Let's check. Triangle DEF. DEF is a what? Isosceles triangle. They are saying EF is what? 18. DE is equal to DF is equal to DF, which is equal to 12. So there is the 12. Makes sense. Makes perfect sense because I've basically interpreted the first statement for the diagram 100% correct so far. Now they are saying calculate the perpendicular height from where? From EF. So from EF there's a perpendicular height that comes from EF to where? To D, to this angle. Does that make sense? Yeah. But remember, if it's a perpendicular height, then it means this base and this line make 90 degrees. So there we have 90 and 90. Now listen to me and listen to me well. Because this is an isosceles triangle, that's 12 and 12. That means, in other words, that this 18 centimeters can be broken down into two, because there is no ways that this vertex here, if you also see this line here, basically this line is a line that basically, because this is an isosceles triangle, this line will cut this EF into two equal, sides. Yeah. So what do we want? We want DF. We want the perpendicular height. The perpendicular height of D to what? To EF. That's what we want. So in order to do that, we need to first find the length here. All right? This length. And then after finding this length, we can use Pythagoras and find who? The perpendicular height. So yes, you guys are right that first and foremost, we're going to take the 18 centimeters and divide it by 2. We get 19 centimeters. Right? So that means that's 9 centimeters. Then we'll take a triangle. Half of that triangle we take. All right? And then we use Pythagoras there. So if I'm going to use Pythagoras, let's say we're going to look at this triangle, because we can use either one. Let's use this triangle. That means this side length, df squared, is going to be equal to what? This height that I'm looking for, this perpendicular height squared, plus what? Plus the other side, plus that other side, which is 9 centimeters. And why am I saying that? It's all because of Pythagoras. Then what's df? Df is 12. Okay, let's just say 12 squared. That perpendicular height I'm still gonna find. the 9 squared, that gives me 81. Then I transpose, because 12 squared is 144, minus the 81, take the 81 over. And remember, I want that perpendicular height. All right, so we use that Pythagoras very nicely. 12 squared, so 144 minus 81, guys, what does that give me? You guys tell me, what does that 144 minus 81 give me? That gives you 63, the square root of 6, so it's 63. And then I take, to get the actual height, I take the square root on either side, right? The square root, so that I get the actual perpendicular height, all right, of 63, which gives me 7,94, as you guys have said. But what did they say here? Round off your final answer to the nearest whole number. So what is the nearest whole number? What do I do if I want to check rounding off to the nearest whole number? What does the 9, what is the function of 9? If this number is 5 or more, that means this number goes up by 1. Therefore, the perpendicular height is going to be equal to 8 centimeters. That is how I would basically calculate the perpendicular height of 8 centimeters. Okay, guys, I hope this makes sense. I hope this makes perfect sense to you. All right, so this question requires us to read, understand what is written here. So your English language becomes important here, 1. 2, your ability to interpret what is written there and put it into a visual diagram. And then 3, applying the right processes to be able to then calculate and get the side length. Those are all important, okay? And guys, as I conclude this paper, because I really have to go now, I think I have 5 minutes before I have to go, and I'll be posting this on my YouTube channel for those that joined in. 2 towers are 50 meters and 66 meters tall, respectively. Okay, hopefully you know what a tower is. So here it is, 50-meter tower. You can see, look at it. Yes, I'll go live tomorrow morning, but first thing tomorrow morning, let's say around about 7 a.m., 6 a.m., 6:30. Gonna go live very early. Just tell me what sections furthermore do you want me to do, so that I can know to prepare for specific things that you want covered. YouTube name, link is in the bio, guys. Link is in the bio, but it's also called Maths is a Game 5 to 7. Thanks to you guys, I just reached, I think, 2.4k followers because of you guys. I really appreciate the support there. All right, so these are the 2 towers, 50 and 66. Find the length x of a wire. So I'll be doing volume and surface area tomorrow then. Okay, volume and surface area tomorrow, definitely will add that into the link. Okay, great. Then guys, Lotin Kwaki maybe later on this evening, okay, because yeah, it's my birthday today, so I have to bounce. I have other plans. If the towers are 60 meters apart, so this tower and this tower, they are 60 meters apart, they say find the length x of a wire that stretches from the top of one tower to the other. So what do we need here? We need to calculate the length. Thank you so much, Lawton. Really appreciate it. Thank you, Manu Klungwan. I really appreciate it. Thanks, you guys, for the birthday wishes. Thank you, thank you, thank you. The length of x. So, do you know the funny thing is, from my learners from my school that were writing this paper, I only had 1 out of the 300 and something learners that we have. Only 1 learner was able to get this correct. And that particular learner actually got the total full marks, the total 75 marks for this paper, which was amazing. Yeah, so Mapagati, very good. It's reflection and theorem of Pythagoras. So basically here, guys, yeah, you know, we need to just apply our minds. All right, so hidden here is Pythagoras, but how? If the length from here to there is 60, then from the top of this tower, the smaller tower, to here, okay, would also be 60 meters. Does that make sense? But remember, this is a horizontal length from here to there. So this length would be perpendicular to this vertical tower. Does that make sense? Then if you look at the full length of the tower, it's 66. The length of this tower is 50. So we want the distance from here all the way to there. Right? I hope that makes sense. So at least I hope we all understand that if this is 60, that is also 60 on the same horizontal plane. From here to there is 60, so it would also stand to reason that from here, top of the tower, I don't know why my thing is going blurry now, it's actually irritating me a lot. That would also be 60, right? Then from the here all the way to the top, is there a way of finding this length, guys? Knowing that they wrote on the 5th, guys, the 5th of November. My learners are done with maths. They wrote maths paper 2 first, and they wrote GEC in the week. So they are done. From here to the top, okay, is 66. From here to there, the top of this tower is 50. So sold out, thank you so much. To get the length here, we would take the entire 66 and then subtract, because from here to there is also 50, like this is 50 this side. Then we'd say 66 minus that 50, which is 100% correct, which will give us 16. Now do you see, for our right angle triangle that we want to utilize Pythagoras for, we have 60, we have 16, we want x. So we can calculate the length of x using what? Pythagoras. So that's what was needed here. That's what was needed. And too many learners didn't see that, and they lost 4 marks. You know, some learners saw that there's this length, but then they could not finish off or see Pythagoras. So yes, this is what we call a level 4 type question, where you're required to piece together some of the concepts you've learned in other aspects and then sort of like utilize those to help you answer the question. Okay, so there's a bit of logic, analytical skills, and then being able to interpret written information so that the diagram makes sense. Okay, and I'm sure, guys, you can calculate that, so I'm going to leave that one. I'm not going to do it for you, but I hope you understand the point. So the marks came with getting first the length of the missing sides of the right angle triangle, acknowledging that the 60 and the 16, getting that 66 minus the 50 to get the 16. Okay, team, how did I get 16? Tim, these are 2 towers. All right, this one is 50 meters tall, this one is 66 meters tall. This here is 60 meters. So we can calculate the length from here to there, all right, mid sort of like way. That is 60 as well, because if that is 60, that is also 60. Then the full length of the tallest tower is 66 meters. Part of the length for this big tower is represented by this small tower, which is 50. So it means from here to there is 50 as well. How much more do you need to get 66 from 50? So that's why you say 66 the total minus the 50, which is the part, which gives you 16. So that means from here to there is 16 meters. Then that's how you get 66 minus 50, which gives you 60. Then what do? You look at this triangle. You want x. You have this side length, which is 60. You have that side length, which is 16. So I wrote this right angle triangle on the side. Then you use Pythagoras to solve for x. So you would start it off by saying x squared is equal to, because you know for Pythagoras it says the square of the hypotenuse side is equal to what? The sum of the square of the other 2 sides. and then you do the calculation. So I'm going to allow you guys to do that, and then in the comment section in my YouTube channel, you guys can actually indicate to me what is the value of x and what did you get, because the steps would be important, and then getting your final answer. Remember, whenever you use Pythagoras, you write the reason. You don't not write the reason, because to simply write the statement and not write the reason does not really help us out. Mapagat, you can't find my link in the bio. Please help with your name. It's Maths is a Game. I said the link of the YouTube channel is Maths is a Game. The link should be in my bio, guys. I posted the link. It's in my bio. The link is in my bio. Maths is a Game. Maths is a Game. YouTube, Maths is a Game. The profile picture of in the YouTube page is you actually have a white background. A white background with the inscriptions Maths is a Game in black. All right, yeah, you'll find it there. You guys just helped me reach just a little bit over 2,000 followers most recently because of doing these live lessons, and I really appreciate that. Thank you so much. It means a lot. Being my birthday, that much more, it means so much more to me. So thank you so much, guys. I'm gonna love and leave you. This was basically the conclusion or the end of this paper. You can do this calculation on your own, and please make it a point that you do the most. Thank you so much, guys. I really appreciate you guys. I will definitely post the whole paper. So brain you did, don't worry. Mapagati, thank you so much for joining, and thank you for the birthday wishes, and I'll see you guys when I see you again, whenever that is. Spa, thank you so much. Love you too, guys. Love you too. I wouldn't be dedicating some time obviously even on my birthday and come here and help you out unless, of course, there's definitely that importance in me that you guys do well. Thank you so much. Have a good one, have a great one, and we'll see each other again. Thank you, babe. Thank you. I usually call your mother, who goes by Babes forever, but yeah, thank you so much. We're passing with you. Definitely do. I won't forget the paper. I'm gonna be taking pictures now and posting it. Okay, don't worry. Cheers, guys. Cheers. Bye.